idem cez nejaký ten LibreOffice prezenter.
Slovenský, anglický, ako bude?
Slovenský. Čo? Vážne? No toto. Horšie, že to tam nikde nebolo uvedené. Polka ľudí sa možno postaví a odíde.
Môžeme? Tak krásne dobré ránko. Vítam vás tu všetkých, ktorí ste prišli dneska, aj tí, ktorí ste boli už včera. Vítame Tomáša Hulatu z Pixel Federationu a bude nám dneska krásnych 35 minút rozprávať o pod disruption a nejakej reachability k tomu. Takže prenechávam slovo.
Super, ďakujem. Takže asi to odštartujeme. Vítam vás na dnešnej prednáške. Názov už bol spomenutý, je to pod disruption and reachability. Disruption je nejaké teda narušenie. Poznáme dobrovoľné a nedobrovoľné. Hej. Nedobrovoľné je napríklad, keď dojdú resursy a zauraduje OM killer a zabije vám procesy na pode, alebo ja neviem, noda crashne, alebo je nejak korupnutá. A potom máme také dobrovoľné, čo je vlastne nejaké managementové, kedy buď omylom smažeme pod, alebo sa drainuje noda, lebo ja neviem, autoscaler sa rozhodol, že to poupratuje a potom ešte taký častý prípad, aspoň u nás v Pixli toho prerušenia je, že škálujeme dosť, všetky deploymenty skoro, škálovanie smerom nahor samozrejme je štart kontajneru, to nie je žiadne narušenie, ale potom keď opadne ten load, tak škálujeme smerom nadol, aby sme ušetrili nejaké tie resursy. A v tomto prípade nastáva určitý problém, ktorý by som dneska chcel rozobrať. Prakticky to škálovanie smerom nahor, ako som už spomínal, to nie je problém. Tam je readiness proba, ktorá vyhodnotí, kedy je aplikácia dostupná a začne serovať trafik. Škálovanie dole, tam na niečo narážame, takže by som dal takú ukážku, nech to tu dlho nenaťahujem, nech vidíme ten problém a potom si ho nejak bližšie rozobereme. Takže skúsime mať deployment, ktorý je naškálovaný, bude nám serovať trafik, ktorý budeme requestovať curlom a ten zoškalujeme dole. Ja tu asi budem trochu ukazovať k tomu. Pozreli sme si deployment, vidíme, že má nejakých 30 podov. Pozreli sme si servisnú adresu, pozreli sme si endpoint slices, čo sú vlastne po novom endpointy. Vidíme, že nejaké 3 adresy nám ukázalo, plus 27 ďalších. Tu, no a teraz začneme ho curlom obstreľovať so sleepom 0,5 sekundy, čiže 2 requesty za sekundu. Teraz v druhom terminále vidíme, že ideme ho zaškálovať. OK. No, čo sa stalo? Zaškáloval sa deployment a zrazu nám to tu vybuchlo. Hej. Tuto jeden curl vybuchol hneď, to bol asi TCP reset. A vlastne to, čo nám tu stojí, je ďalší curl, ktorý timeoutuje. Hej, curl má, myslím, že defaultne nejakých 300 sekúnd, takže tu by sme sa načakali. Tu ukazujeme, že ešte stále sú tam živé body a nefungujeme. Takže o tomto probléme chcem hovoriť, nejak si ho rozoberieme dopodrobna. Najprv si niečo povieme teda o servise ako takej. Hej, že čo to je servisa? Je to vlastne nejaký natívny, vysokodostupný balancer, ktorý teda nás prístupňuje nejakú skupinu podov špecifikovaná aj selektormi. Prakticky servisa nemá nič spoločné s nejakým replikasetom alebo demosetom. Ide priamo na pody. Keď vytvoríme servisu, vlastne vtedy nám API server alokuje túto nejakú cluster IP, keď sa bavíme o servise typu cluster IP. Je to z nejakého rangeu, ktorý je vykonfigurovaný. A v momente teda, keď ju aplikujeme, tak endpoint controller, respektíve ponovom endpoint slices controller, nám začnú vytvárať endpointy. Tie si ukážeme. A vlastne to, kto implementuje functional servicey ako takej na jednotlivých nodách, je Kubeproxy. Tam sú štandardne dve možnosti. Bude to pomocou IP tablov, čož není úplne najvýhodnejšie z pohľadu performanceu, alebo sa používa IPVS. A potom pri nejakých iných networkoch sa môžeme baviť o úplne iných implementáciách, ale toto je základ. Takže tu sa pozrieme na nejaký endpoint slice. Ten grep, čo tu používam, tým sa nesnažím nič filtrovať, len som to chcel ofarbiť, nech to není také nudné. Takže toto bol trojpodový deployment. A tu vidíme 3 IP adresy. A nazval som to nejak deep dive, pretože sa pozrieme skutočne na tú implementáciu. Takže na každej node sú IP tably, ktoré vlastne tú servisnú adresu pomocou NATu odchytia a vlastne prenatujú ju na tie jednotlivé adresy. Tu je nejaký štatistický modul, ktorý vlastne rieši tú distribúciu. Tu vidíme, že 0,3 preletí prvým pravidlom, 0,5 druhým a zvyšok zoberie ostatné. To samozrejme vychádza 0,6 nám neprejde, z neho prejde polka, čo je zase 0,3 a zvyšok sú tie ostatné 0,3. Takže takto je rozbalancovaná servisa. A tu sa pozrieme podrobnejšie na to, čo je vlastne endpoint slice. Endpoint slice teda obsahuje nejakú tú konkrétnu adresu, obsahuje nejaké tie podmienky, ktoré sú vlastne z readiness proby, či je ready, serving, terminating a podobne. Tuto na spodu vidíme, že by bola druhá adresa, keďže som si ich vypýtal všetky, boli by tam všetky 3. Vidíme, že referencuje konkrétny pod, na ktorý sa viaže tá adresa. A tu ešte pokračovanie, čo je dôležité, že ten endpoint slice vznikol na základe toho, že sme vytvorili servisu. My sme teda vyexpozovali nejaký servis. Tu vidíme, že je to manažované endpoint slice kontrolerom a že to patrí k servise s názvom app. Ono je to tu ešte raz. Je tu ovná referencia. Znova vidíme, že patrí pod servisu s názvom app a nejakú UIDčka. A tu je port, čiže tá definícia endpoint slice je taká komplikovanejšia. Pôvodne pár verzií Kubernetov dozadu to boli iba endpointy, ktoré mali nejaké svoje limity. Tak sa postupne prechádza na endpoint slices, ale momentálne budem hovoriť o endpointoch alebo endpoint sliceoch zameniteľne. Takže to, čo sa udialo. Tu sa budem baviť o 2 udalostiach alebo reťazí udalostí, ktoré sú na sebe nezávislé, ale dejú sa naraz, takže sa kľudne môžeme baviť aj o race condition. Takže požiadali sme teda, alebo niekto požiadal o deletovanie podu API server, že na jednej strane sa idú riešiť endpointy, na druhej strane sa ide riešiť samotný kontajner, respektíve pod. Takže tu vidíme, že prichádza k updateu endpointov a tu nám Kubelet pošle sigterm do všetkých kontajnerov v pode. Keďže tieto udalosti vôbec nejak nie sú synchronizované, všetko to závisí na vyťažení API serveru a respektíve príslušných kontrolerov, tak tam dochádza k rôznym prakticky rýchlostiam, kedy sa ktorá udalosť stane. Keď sa updatenú tieto endpointy, tak samozrejme oni na niečo slúžia. Tá Kubeproxy, ktorú sme si ukazovali, ktorá ich implementuje pomocou IP tablov alebo IPVS, je nejaký listener alebo watcher cez buď watch API alebo podobne na API servery a reflektuje všetky zmeny, tak aby servisa vlastne vyzerala podľa požadovaného stavu. Potom tu máme ingress controller, ktorý takisto sleduje zmeny všetkých servis a príslušných endpointov, respektíve endpoint sliceov, a potom tu máme ďalšie aplikácie. Core DNS to sleduje, aby vedel teda resolvovať servisy, Prometheus, aby vedel koho scrapovať a podobne. Tu nám po príchode Sigtermu začína terminácia, ktorá defaultne môže trvať 30 sekúnd, vyslovene záleží od aplikácie. Taký Nginx, keď terminujeme, tak prestáva servovať nové requesty a vlastne snaží sa clean upnúť staré, doservovať. A tu vidíme už samotnú realizáciu tých zmien, ktoré si všimla kubeproxy, že updatenete IP tably. To znamená, že vymáže nejaké to pravidlo z nich toho konkrétneho kontajneru, respektíve podu, ktorý bol deletenutý. Tu nám ešte prichádza sick-kill, keď si aplikácia nedá povedať v rámci tej grace periódy, tak po jej uplynutí ona je konfigurovateľná, po jej uplynutí tam pošle kill a nebabre sa s tým. Takže pre stop hook je nejaká možnosť modifikovať tento cyklus toho ako životného cyklu kontajneru. A tu vidíme, že je zavolaný tesne predtým, než je kontajner terminovaný. Ukážeme si nejakú jeho definíciu, ktorá môže byť takto sprosto jednoduchá. Napríklad, že ho slípneme na 20 sekúnd a to znamená, že ten sick term sa v našom prípade oneskorí o 20 sekúnd, čož nám pomôže. Ukážeme si ako. Tuto máme kontajner, ktorý ideme zabiť a je to teda bez toho pre-stop hooku. V jednom terminále pozeráme logy, ja som ho spravil taký verbose a v druhom ho teda zostrelíme. Takže tu vidíme, že dostal sigterm v momente, kedy sme dali delete. Samozrejme, ja som ten sigterm odchytil a teda nerobím žiadny shutdown. Čakám, kedy skončí grace perióda, aby to zabila tým sick killom. Tu vidíme, 30 sekúnd ubehlo, kontajner to zabilo. Teraz si to pozrime s tým pre-stop hookom, ako sa modifikovalo to správanie. Znova dáme si logy tej servisy, teda logy toho podu a zabijeme ho. Tu vidíme pre-stop hook, ten nabehol s tým sleepom 20 a vlastne som tam dal poznámku, že v tomto momente sa nám začínajú už klínovať tie endpointy. Pre-stop hook skončil, 20 sekúnd ubehlo a až teraz prišiel ten sick term. A zase tu máme nejakých 30 sekúnd, pretože žiadnu termináciu nerobím, takže čakám na ten kill. Dobre, asi nemusíme úplne čakať do konca, takže to dáme ďalej a ukážeme si, ako to vyzeralo s tým pre-stop hookom. Ja by som vám dodal, že tá timeline je trošku taká zvrhla v tom, že tuto sú udalosti, ktoré možno trvajú milisekundy a potom sú tam zrazu udalosti, ktoré trvajú sekundy, ale na ilustráciu to poslúži. Takže zase tu máme tieto dve nezávislé chainy eventov, kde sa idú upravovať endpointy a kde sa ide zabiť samotný kontajner. Tu vidíme, že nám kickol ten pre-stop hook a vlastne ten dal čas tomu, aby sa toto všetko poupdateovalo, čiže sa nám nestane to, že by sme mali aktívne endpointy a už terminujúci alebo nebodaj mŕtvý kontajner. Čož vlastne bol ten prípad, čo sme videli s tým kurlom na začiatku. Tu vidíme, že po ubehnutí toho hooku prichádza sick term, tak ako sme to videli aj v tých logoch. A vlastne až keď tam už to IP table spravidlo alebo IPVS, keď vyradilo tú IP adresu zo zoznamu, tak až vtedy začína terminácia. A taká poznámka k pre-stop hooku je oficiálna, že vlastne Kubelet zabíja v pode tie kontajnery, samozrejme tiež nejakým náhodným spôsobom v jednom momente paralelne teda pošle sick term všetkým kontajnerom v pode. A to neznamená, že všetkým príde v jednom momente. Takže keby sme chceli urobiť nejakú synchronizáciu, musíme použiť tento pre-stop hook. Ono napríklad, keď máte pod, kde máte nejaký, server a máte tam ešte nebodaj Nginx ako proxinu, tak sa vám môžu stať nejaké záhadné 502, keď príde takýto request na termináciu a najprv vám to zabije ten backend a Nginx ešte stále servuje. Backend už je nedostupný, takže Nginx servuje 502 a až potom to zabije Nginx. Hej, no sa tu nebavíme o nejakej dlhej dobe, tu sa môžeme baviť maximálne o sekunde, dvoch, ale samozrejme záleží od toho, aký máte rate. A podľa toho sa vám tento problém nejak manifestuje alebo nemanifestuje. Ono je napríklad horšie, keď sa tento problém manifestuje na takom DNS-ku. Predpokladám, že všetci štandardne na DNS-ko pristupujete cez servisu. A keby vám to DNS-ko, respektíve core DNS alebo niečo podobné a nejak zásadnejšie škálovalo hore-dole a v nejakých väčších objemoch, tak v momente, keď vám zabije viacero podov DNS-ka, tak vám vlastne tento problém vypláva na celom klastri, pretože nebudú schopné pody aspoň chvíľu resolvovať. Ja som sa pozeral na nejaké service meše, že či nám teda vedia pomôcť. Čo sa mi ľúbila je implementácia od Cilia, ktorí proste nahradili Kube proxy s tým svojím eBPF, ktorým riešia aj celý routing. Hej, že tie sidecarové service meše sa mi neúplne ľúbia, takže skúšal som tento problém, ktorý je skôr dizajnový, zreprodukovať na service meši. Preto som sem dal aj otáznik. No, a tu už není video, lebo som mal celkom problém to zreprodukovať, takže situácia sa podstatne zlepšila s týmto Cilium Service Meshom, ale stále sa to deje. Hej, keď sa pozrieme na to, tak vidíme, že ten kurl, ktorý som púšťal aj predtým, tu dokonca je bez sleepu, takže bol to jeden request za sekundu. Nám tuto vybuchol niekoľkokrát, samozrejme to sú tie kurly, ktoré idú v tom lúpe za sebou. Ako preskúmať vlastne, čo sa deje, myslím, že toto by sme asi TCP dumpom nepochytali, keďže to je kernely a rieši si to Cilium. Oni majú takú zaujímavý nástroj, ktorý sa volá Hubble. Má aj UIčko, to UIčko zatiaľ je podľa mňa také amatérske, takže som použil celý na to, aby som zistil, čo sa vlastne stalo. A tu vidíme, že tu boli nejaké resety. To budú asi tieto 0 milisekúnd, kedy hneď dostal odpoveď, respektíve sa nevedel konektnúť. Hej, to bol ten reset. No a tuto tie posledné vidíme, že stale or unroutable IP dropped. A tu vidíme, že tento posledný curl trval prakticky, on timeoutoval, až potom vybuchol, lebo vlastne tie sync pakety boli dropnuté, takže nikdy mu nedošiel synak, tak čakal. Nedošiel mu ani reset. Takže sa mi to podarilo zreprodukovať aj s service meshom. Takže jediné riešenie je pre-stop hook, ktorý nie je úplne že finálnym riešením, ale nazvime to smart proxy. To, čo nás odtieni od tohto problému. Ja mám tu spomenuté, že teda pre-stop hook nám vlastne synchronizuje alebo zaručí, že pod sa terminuje až potom, ako sa upratali endpointy. To znamená, že všetky aplikácie, ktoré sledujú endpointy, tam nevidia endpoint, ktorého pod by už neexistoval. No a tu sa môžeme baviť o tom, že používajte Nginx controller všade tam, kde je to možné. Hej, my prakticky nepristupujeme na servisy, ak sa nás týka tento problém, ale ideme proste normálne cez doménu, cez controller. Pretože on si robí healthchecky, dokáže bufferovať request a dokáže vyskúšať aj viacero endpointov, ak sú nastavené retry. K tomuto môžem povedať asi nič. Dobre, čo som chcel povedať? Áno, že nie samozrejme všetky protokoly sú také nejaké atomické ako HTTP, kde je nejaká request response, takže keď je proste nejaký TCP connection natiahnutý na pod, tak tam moc není pomoci. Prakticky Ingress vie preproxovať aj iné, ale najviac si vieme pomôcť pri HTTP. Potom môžeme sa pobaviť o DNS-ku. Nejak sa nám to tu celé nezmestilo, ale ak sa tento problém manifestuje na DNS-ku, tak jednoduchým riešením je použiť node local DNS. Ten beží vlastne na každej node. Jeho výhoda je, že cacheuje, takže keby bol aj nejaký problém, stále je schopný vrátiť z cache. A samozrejme taktiež má nejaké svoje healthchecky. A vie si vlastne ošefovať nejaký prípadný problém s konektom na upstream. Takže toľko to asi k prezentácii. Ja ešte možno spomeniem nejaké zaujímavosti, čo sa nám postávalo, kde som ukazoval, že stačí sleep. Hej, nie všetky kontajnery sleep majú. My sme napríklad mali vektor, čo je nejaká varianta na Fluent Beat a podobné agregátory, kde vstupom je HTTP server a výstupom myslím, že bola Kafka. A ten nám celkom zásadne škáluje, lebo všetky projekty do neho s dosť vysokým rateom reportujú. A teda mali sme tam tento pre-stop hook so sleepom. Potom sme to updateovali a namiesto Debianieho kontajneru sa tam ocitol distroless, alebo from scratch, ktorý sleep nemal, takže sa tento problém hneď začal manifestovať tým, že pre sleep nebol, všetci si začali sťažovať, že im to eroruje. A teda kolega to nejak nechcel investigovať, chcel to rýchlo vyriešiť, takže načkaloval to, vypol škálovanie a až potom sme zistili, že v čom je vlastne problém. No tak toľko za mňa asi všetko, tak skúsme nejaké otázky. Áno.
Stalo by za to místo sleepu skúsiť použiť Kubernetes klient a proste kontrolovať přes API, jestli je ten void slice updateovaný, a sa zbytečne nečekal třeba 20 vteřin.
Ako spraviť si vlastnú implementáciu v princípe. Áno, no keď sa budete baviť s API serverom a zisťovať si, aký je stav, tak možno aj áno, otázka je, kedy on je updatenutý. Je možné, že aj tam bude nejaký delay, že to nebude úplné riešenie. Hej, prosím?
Kubernetes má defaultne všetko kešované, nemáš vždycky reálne.
Tak. Áno. Hej. Nejaká ďalšia otázka? Aha. Áno. Readiness proba, tá je fajn, ale samozrejme, tu je to isté, na čo sme aj odpovedali. Ten flow je nejaký. Pokiaľ tá readiness proba s intervalom, ja neviem, aj sekundou, je vlastne presne to, čo strácame. To je nejaká tá sekunda, kedy je to v neznámom stave. Pokiaľ sa to celé vyupdateuje, tak tá diera tam je. Takže tá readiness proba má failure, dajme tomu, aj keby bolo len 2, to sú 2 sekundy. A to je presne to okno, kedy sa tento problém manifestuje. Takže readiness proba nepomôže.
Ale reálne, aký je to väčší problém?
Ako, áno, je to edge case a možno sa vám deje, možno sa vám nedeje, záleží fakt od rateu. A pri DNS-ku by som povedal, že to je aj väčší problém, keďže v tom momente vyerorujú snad všetky aplikácie v klastri, ale samozrejme sa aj recoverbnú a je to, ja neviem, ten problém sa manifestuje možno 2 sekundy. Takže je to skôr o nejakej tej citlivosti tých aplikácií a či to stojí za tie problémy, alebo tu použijeme nejaký jednoduchý synchronizačný trik, aby sme sa toho problému úplne zbavili. Všetko. Tak, OK. Tak ďakujem za pozornosť. Dúfam, že vás to trochu obohatilo, aj keď je to len teda edge case. Ja som ho vypol. Aha. Sikterm v prestobovku. No my ako dáva, my tým prestobúkom chceme ten sikterm oddialiť, hej, a on tak či onak príde. Takže v rámci nejakej tej synchronizácie si viem predstaviť, že by ten prestobúk nebol sleep, bol by to niečo komplikovanejšie, kde sa nejak dohadujú 2 prestobúky, jeden napríklad pre ten Nginx a druhý pre tú aplikáciu, hej, a povedia si, že teraz ich ideme upratať. Hej, to si viem predstaviť, ale neviem, čo by sme tým nejak extra získali, keďže on potom príde.
A zdieľa prestobúk proces namespace? Môžem ja poslať signál napriamo?
Jak to myslí? Ešte raz?
Kontajnery sú oddelené, takže ja nevidím na PD procesy jedného kontajnera do druhého. By default. Je to potrebné povoliť v nastavení.
Áno. Ja si myslím, že keďže je per kontajner, že vidí to isté, čo štandardný kontajner. Takže budú separované. Hej, ten prestop hook nám nezabije oba kontajnery. Hej, je per kontajner, takže respektíve nezabije. Beží v jednom kontajneri, čokoľvek robíme, tak vidíme ten jeden kontajner, v ktorom beží. Hej, čiže môže to byť samozrejme skript, ktorý tam urobí čokoľvek, môžeme sa nejak synchronizovať cez nejaké temporary súbory, ktoré sú nazdieľané cez oba kontajnery a podobne.
Tak jo, ďakujeme teda ešte raz. Máme teraz krátku prestávočku, 10:10 začína ďalšia prezentácia.
Ďakujem.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
stealthier,
engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
oh my God, each other,
for our neighbors,
our kids,
People with an I or T in their job titles.
for new leaders dragging century-old giants into the future,
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
I'm not.
people with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people,
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Tak teda pokračujeme ďalej. Vítam Zdenka a porozpráva nám konečne niečo o IBF-ku. Teda užij si to.
Ahojte, skrátke, moje meno je Zdenko Vrábel. Áno, prišiel som porozprávať niečo, ani neporozprávať o EBPF-ku, ale skôr ho ukázať, lebo všetci o tom rozprávajú a možno je aj dobre to ukázať, ako to vyzerá. Tak. Skrátke, som programátor. Neviem, koľko z vás máte radi programovanie? Nemusíte byť vyslovene. Super, lebo bude nejaký kód, tak... poďme k tomu. Ešte druhá otázka. Koľko z vás cca tušia, čo EBPF je? Dobre, tak veľmi skrátke ja to vysvetlím. EBPF je niečo v kerneli. Je to malá virtuálna mašina priamo v kerneli. Veľmi v skrátke. Umožňujeme, vlastne ona je tak akože rozvešaná všade po kerneli a dovoluje nám sa huknúť na nejaké veci v rámci toho kernelu. Je ich dosť, tých vecí už pribudlo pomerne dosť. A výhoda je, že keď sme chceli napríklad network, budeme sa dosť baviť o networkingu, takže keď sme chceli niečo modifikovať alebo v rámci toho Linuxu, museli sme hrať v rámci pravidiel hry, to znamená, že Linux má nejaký netstack a v rámci neho sme sa museli pohybovať. Bohužiaľ, nebola tam nejaká veľká sloboda a BPF alebo EBPF túto situáciu celkom zmenilo tým spôsobom, že nám dovolí nejakým spôsobom tam injektnúť náš vlastný kód za behu. Toto je veľmi dôležité, lebo predtým to bolo samozrejme možné, len to znamenalo vykompilovať kernel a teda ako pečovať ho. Z BPF mám tu možnosť, že je to fakt virtuálna mašina, môžem tam injektnúť nejaký kód a dať ho a atačnúť ho na nejakú vec alebo nejakú udalosť. EBPF dneska už nie je len o networkingu, v podstate dá sa to atačnúť na syskoly a často sa hovorí, že EBPF, ale treba si... Mňa prekvapilo, že koľko typov programov EBPF je. Hej. Čiže nie je to len jedna vec. Skrátke, ja budem vlastne ukazovať niečo, čo sa volá XDP a to je vlastne spôsob, ako sa ten môj custom kód dostať úplne až na network interface, čo je, si myslím, veľmi zaujímavá vlastnosť. A nejakým spôsobom pristúpiť k tomu paketu, ktorý na ten interfejs príde normálne v RAW forme. A to je akože v tomto smere a mať nad tým nejaký kód. Okrem toho, že to je nejaká virtuálna mašina, do ktorej dám kód, tak ja by som ešte chcel komunikovať s nejakou kontrolnou aplikáciou, ktorá žije už v nejakom user space. A to sa deje v podstate pomocou tzv. Map. Čiže to je v skrátke EBPF. Ale hlavne si to poďme ukázať. Taký úplne najjednoduchý... Píše sa to viac menej stále len v C-čku. Existujú nejaké experimenty s Rustom a teda inými jazykmi, ale momentálne ako ten jediný programovací použiteľný jazyk je C-čko, kde sa vykompiluje nejaká binárka a tu si potom loadneme do kernelu. Čiže začneme úplne najzákladnejším. Ako keď máme program main, tak my začneme vlastne nejakým vstupným bodom, ako vstupnou funkciou. Takže si začneme písať, áno. Toto je vlastne ako keby main, bude to nejaký KCD program. Každý EBPF program dostáva nejaký argument, to je nejaký kontext. V tomto prípade je to XDP. V prípade, keby sme riešili syskoly, a teda tam bude nejaká iná datová štruktúra. A má nejakú navratovú hodnotu. Ešte potrebujeme nejaké headre. No a tento náš jednoduchý ako program vlastne neurobí nič iné, len vráti takzvanú navratovú hodnotu, že paket proste prejde ďalej. Aby som mal nejakú kontrolu nad tým, aby som videl, že to funguje, tak si tam dám nejaký print. No a ešte posledná vec je license. Sú tam nejaké sekcie. Toto je takto. Keď som ukazoval vlastne tento obrázok, je tu nejaký verifier. Keďže je to zásah do kernelu, vy tam dávate nejaký kód, tak nemôžete tam dať hocičo, aby ste ten systém celý nerozhasili. Tak je predtým nejaký verifier, ktorý to vlastne nejakým spôsobom snaží sa ten kód alebo tú binárku validovať, či je OK. A jedna z tých requirementov je license. My sa vlastne budeme snažiť o niečo takéto. Budeme mať nejaký vstupný program, cez ktorého budú chodiť vlastne pakety, zatiaľ ich dávam pas. V tom XDPčku vlastne môžete robiť také tie základné veci, ako potom forward, čiže vrátim to naspäť na interfejs alebo to dropnúť. Jednoduchá funkcionalita, ale dá sa s tým celkom veľa akože robiť. Takže poďme na to. Jednoduchý program, začali sme. Treba si to vykompilovať. Tu si použijem takýto ťahačík. Dobre. Cut. Snažím sa ísť rýchlo, lebo času nie je veľa. Kompiluje sa celangom, čo je v podstate, neviem, kto z vás to pozná, skrátenie je to LLVM. Výsledkom musí byť nejaká binárka, ktorá má target to BPF-ko. Takže si to vykompilujeme, dostávam binárku. KCD, toto je môj program. Teraz ho potrebujem v podstate loadnúť do kernelu. Loadovanie BPF programov do kernelu sa dá robiť rôznymi spôsobmi. Linux proste poskytuje nejaké systémové volania na prácu s BPF-kom. Aby sme zase nemuseli v C-čku nejaké systémové volania takto sa škrabať, tak existuje jeden super nástroj, volá sa BPF Tool, ktorý vám vlastne dáva takéto, vieme to z command line veľmi rýchlo odpaliť, čiže samozrejme sudo. Všetko to treba robiť s veľkými právami, keďže je to zásah do kernelu. Proc, load, ideme, môj program a ešte, ja si to takto pinnem, BPF, KCD. V rámci file systému existuje takéto miesto, kde tie BPF viete pinnúť. Poďme na to. Vyzerá, že prešlo. To, ako sa to dá skontrolovať, je zase pomocou BPF toolu. Proglist. Toto je vlastne zoznam viac menej všetkých BPF programov, ktoré ja v kerneli natiahnuté mám a tu už vlastne mám môj program. To je ten KCD proc. Je to typu XDP a má IDčko 72. Dobre, ja som ho natiahol, ale momentálne ešte on nič nerobí. Ja na to, aby ten XDP program fungoval, ja ho potrebujem nejakým spôsobom attachnúť na nejaký interfejs. Takže poďme si to attachnúť na nejaký interfejs. Ja si medzi tým spustím proste v Dockri nejaký jednoduchý TCP server, ktorý bude počúvať na porte 8888. To bude mať za následok vlastne, že sa mi vytvorí nejaký virtuálny interfejs na mojom stroji, kde to beží. Je to vlastne tento VET, takýto hrozostrašný. A ja tento môj program vlastne chcem nejakým spôsobom attachnúť na tento interfejs. Zase sudo BPF tool, teraz použijem net XDP, pretože ide program XDP, ID 72, ktorý vlastne ktorý tu bol loadnutý, dev, na aký interfejs ho vlastne chcem attachnúť. Keď som to teda správne napísal, čo som nenapísal, čiže ideme, čo sa mu nepáči. Attach, jasné. Takže attach mi vypadlo slovičko. Dobre, teraz je tam. Dá sa to veľmi jednoducho overiť. Ak si pozriem ten interfejs, tak ono mi to vlastne už vypíše, že k tomuto interfejsu je attachnutý tento BPF program, čiže on tam už reálne je. A ako ste videli, ono niečo vypisuje. No a kam to vypisuje? Vypisuje to... keď si pozrieme syskernel tracing, trace pipe, tak tuto by malo vypísať. Len momentálne nič vypisuje, lebo mi chýba trafik. Takže ja urobím nejaký telnet. Je to vyťahnúce cez port forward na 8888, čiže localhost 8888 a niečo pošlem, hej. Do môjho kontajnera vlastne cez ten interfejs pretiekli nejaké pakety, čiže ja by som mal vidieť ten môj print. Čiže môj program je tam, nejakým spôsobom cez neho tečú pakety, vypisuje ten print. No to je úplne akože hello world by som povedal, je to základ. Vidieť, že tam niečo sa deje. Momentálne používam nejaké akože BPF tool a teda, ale aby to bolo niečo zaujímavejšie, vymyslíme si nejaké lepšie scenário a to úplne tiež začneme úplne jednoduchým, aby to nebolo prehnané. Urobíme si takú štatistiku vlastne, že budeme agregovať IP adresy a koľko paketov pre každú IP adresu prišlo, také jednoduchá observability, alebo ako to nazvať. Čo k tomu budeme potrebovať? Budeme k tomu potrebovať BPF program, ktorý vlastne vyparsuje z toho paketu nejakú adresu. Budeme potrebovať nejakým spôsobom to loadnúť, ale nechceme to robiť cez BPF tool, my to chceme mať krásnu aplikáciu binárku, ktorú potom môžeme distribuovať, na to použijeme Go. A chceme, aby tá kontrolná aplikácia s tým môjim BPF programom vlastne nejakým spôsobom komunikovala. Čiže aby tie štatistiky posielala nejaké tej mojej kontrolnej aplikácii a aby to, expozovala to, ako dávala to nejaké, hoci kde. No proste to, tam už v user space už sa môžeme hrať. To sa rieši vlastne, táto komunikácia bude riešená cez mapy. Na to, aby som vlastne nejakým spôsobom celú tú režiu okolo loadovania a teda si uľahčil, existuje výborná knižnica pre Go, za ktorou sú ľudia presne od Cilia, Cloudflare a teda. Veľmi jednoduchý názov, eBPF. Veľmi vydarená knižnica, ktorá veľmi vie pomôcť s celým tým boilerplate a celým tým humbukom okolo toho. Čiže poďme si napísať teda nejakú kontrolnú aplikáciu v Go. Budeme ju volať KCD Go. Začneme už štandardne mainom. Prvé, čo budeme potrebovať, je takáto maličká klauzulka, alebo takýto kód. Vlastne to je niečo, čo nám zabezpečí to, že ten C-čkový KCD, ten môj eBPF program, pre ňoho vygeneruje ten BPF2 Go tool, ktorý je súčasť eBPF knižnice, samotné binárky a nejaký Go proste kód, ktorým to potom môžeme akože lepšie manažovať. Čiže poďme na to. Go, build, vybuildujeme to. Čiže ja som dostal momentálne, Go generate. Tak, teraz to trošku pošrotí. Internety. Ešte neexistuje môj KCD, lebo ja som si ho nechal v inom foldri. Ja si ho nakopírujem. Je to v podstate ten môj main. Ja si tu dáme ešte nejak akože Go, aby sme to vedeli rozlišiť. A ideme generate. Dobre, teraz mi to vygenerovalo nejakú haldu kódu alebo haldu súborov. Go súbor a tú binárku. Keď sa pozrieme do toho Go, no poď. Som nervózny. Z čoho? Tak vidíme, že vlastne sú tu nejaké funkcie práve na také tie veci ako loadnúť a hlavne sú tu veci typu čo loadnúť. Čiže ja sa to teraz pokúsim nájsť. Áno, je to môj KCD proc. Toto je vlastne veľmi dôležité. Toto budeme používať. No tak vygenerovalo mi to nejaký Go kód, takže pokračujeme ďalej. Zatiaľ môj main Go nič nerobí, len vygeneroval nejaký kód. Poďme na to. Prvá vec, ktorú potrebujeme, je loadnúť môj BPF program do kernelu. Vlastne to, čo som robil tým BPF toolom. BPF objects, vytvoríme nejakú BPF objects, load BPF objects. Toto je všetko vlastne, ten generátor mi vlastne to vygeneroval. Druhú vec, ktorú budem potrebovať, je interface, na ktorý to atačnem. Ten si pásnem vlastne do aplikácie cez argument. No a poslednú vec, ktorú potrebujem, je ten samotný attachment, čiže attach XDP. Vlastne tá eBPF knižnica prichádza fakt s veľmi, veľmi developer-friendly funkciami pre BPF-ko. Netreba tam nič. Argumenty, to je vlastne ten KCD proc, aby vedelo, že to bude vlastne tento program a ktorému interfejsu to vlastne attachnem. No a poďme rýchlo na to. Poslednú vec, už len nejaký loop, v ktorom sa tá aplikácia bude točiť. Dúfam, že som to saveol. Dobre. Build. Package. Oj. Bojím sa teraz robiť takú vec, že Ježišmaria, človek sa pripravuje a tak toto dopadne. Lognet OS link. Dobre, ja to urobím rýchlejšie. Ospravedlňujem sa za to. Nechcem to spúšťať, alebo by sme trvali sťahovanie kadejakých srand. List. To tak s live codingom, keď človek robí. CTL EBP demo shell. Dobre. Čiže vlastne máme toto a toto si vyčistím, k tomu sa ešte dostaneme. Tieto veci si vyčistím. Ešte si upravím rýchlosti KCD môj C program, kde toto všetko vyhodím. Predbehujem, ale nevadí. Toto sa ospravedlňujem, som to veľmi nevychytal s internetmi. Takto, hej. Čiže go generate. Dobre. Tu máme vlastne to, to je ten vlastne loading, attachment. Čiže poďme go build. No, a sme v tom bode, kde sme chceli byť. Mám KCD Go, ktorej ešte mi tu bude chýbať táto vec. To všetko poruším. Quit, exit. Musím sa... demo. Človek sa pripravuje a takto to dopadne. No. Dobre, máme. Čiže to som tu, toto si zruším, aby ma to nejak... Dobre. Som v bode 0. IP link. Čiže je tu ten Ethernet. Spustím si teda tú aplikáciu CD Go. Pasne mu Ethernet. Sudo. A keď sa nič čo sa pokašľalo, lebo attach tu program a ešte ja som zmazal až moc. Tak. Go build. Dobre. Tak rýchlo som sa dostal do stavu, kde som chcel byť. Vlastne teraz sme tam, kde sme boli. Keď si pozriem demo telnet 8888 localhost. Hej. To je tak, keď človek chce robiť live coding. Dobre. Pakety nejaké prebehli, čiže ja si to ešte raz... Bože, to... No. Pozrieme sa na ten print. syskernel, tracing, tracepipe. Hej, vlastne zase som tam, kde som bol, akurát už mám nejaký Go program, čiže už len rýchlo doprogramujeme a vlastne rozšírime to KCD, ten eBPF programu, tú agregáciu dát a vytvoríme mapu a nasypeme to do mapy v eBPF programe a v Gočku to potom už len vyťahneme. Čiže poďme rýchlo na to. KCDC. To je ten bod, kde sme začali, čiže toto je vlastne, takto sa vytvorí mapa, cez ktorú budem komunikovať s mojim kontrolným programom. Má nejaký typ, tých map je viacero typov, má nejakú size, veľkosť, kde key bude IPv4 adresa a value bude vlastne počet paketov. Tak ako som hovoril, toto nejakým spôsobom to XDPMD, ten vstupný kontext, on vlastne dostáva pointere na paket, na raw paket. Čiže ja to musím nejakým spôsobom vyparsovať, stavať. A ono to v skratke vyzerá takto, že XDPMD má niečo, že data end ukazuje na začiatok paketu, na konci paketu. Paket je priamo raw z interfejsu, čiže tam nájdete tzv. Ethernet header, doslova z MAC adresov, vlastne to úplne to L3, alebo no, za tým ide potom, keď je to IP paket IPv4, tak potom IPv header, z ktorého potrebujem vlastne tú adresu a payload. Nás bude zaujímať vlastne ten IP header, z ktorého vyťahneme tú adresu. Je to práca s bytemi v podstate. To je presne tá funkcia. Ako vidíte, že zoberiem si data end, nájdem Ethernet header, pozriem, či je to IPv4, následne idem, že keď je to IPv4, zoberiem si IP header a z neho si zoberiem destination IP adresu. K tomu sa vrátim, prečo destination. Vrátim jednotku, no a rýchlo ideme, áno. Vlastne volanie tej funkcii, keď zlyhá, že to nebude IP paket, aj tak ho pošli, aby som si neodrezal zase komunikáciu. A tu je práca vlastne s tou mapou. Hej. Pozriem sa do mapy, je tam táto IP adresa, ak tam nie je, pridám ju, ak tam je, použijem built-in funkciu na vlastne inkrementovanie. A to je všetko. Z pohľadu tohto, keď som neurobil veľa preklepov, tak toto prejde, super. Už mám tam aj mapu. Tá eBPF knižnica vlastne okrem programu mi vygenerovala aj mapu, čo je skvelé, čiže v Objects budem mať aj mapu. A tu je vlastne tá slučka, ktorá sa vykonáva každú sekundu a ja do nej už len vlastne potrebujem urobiť print map. OBS, KCD map. Prečo KCD map? Lebo ona sa vlastne v tom C-čkovom kode takto volá. No a potrebujem už len vlastne tú funkciu. Ona zoberie tú mapu a cez mi preiteruje, kde vyťahne IP adresu, počet paketov ako Win32 vypíše. Ja zmenej. To je všetko. Go build. IP link. A už len zavoláme sudo. A keď to pôjde, tak to bude úspešný príbeh, ak nie, tak mi treba. Dobre, mám to tam loadnuté, čiže na výstupe by som už mal dostávať nejakým spôsobom, keď tam prídu nejaké pakety. Áno, IP adresu. Čiže ja tam pošlem aj viac toho, nech tam... Čiže vidím, že vlastne... Prečo je to 172? Zo 172.17.01 prichádza nejaký trafík vlastne do môjho kontajnera. Čiže tak. To je v podstate to, ako vyzerá, ako sa to robí. Samozrejme, pri programovaní tam je ešte ďalej veľa topikov, ktorých by sa dalo otvoriť, ale toto malo byť len také intro, že ako rýchlo tam narvať ten program. Čiže pre vás možno super nástroj BPF tool, ktorým sa to dá investigovať a tak. Hej, a čo som hovoril hviezdička, prečo destination address parsujem a nie source address? A je to tak ako keby naopak. Je to kvôli tomu, že ja to atačujem na interfejs, ktorý je na mojom hostovskom stroji. A kontajnery fungujú tak, že vlastne máte ako keby dve interfejsy, medzi nimi je ako keby taký kábel natiahnutý. Ja som to vlastne na ten hostovský stroj, čiže atačol, čiže je to tam trošku obratené. Aby som chcel, že by to bol source IP adres, tak to musím atačnúť na ten interfejs, ktorý je momentálne v namespaceoch skrytý niekde ako v Dockeri, čiže by som sa tam musel nejak dostať do toho a atačnúť to tam. Preto je to také trošku obratené. Dobre. Rýchlovka. Otázky? Na veľa nebudem vedieť odpovedať. Je to ťažká téma, popravde. Ale je to zaujímavá téma. Ináč ja som user space programátor, úplný šmatlož a keď ja už to dokážem akože takto robiť, tak je to super, že už nemusím byť nejaký fakt kernel nabuchaný typek. Hej, ako, to je tiež jedna. A neviem, či ste si všimli, keď som tam loadoval a unloadoval tie BPF-ka, trafik mi nepadol, to je tiež jedna skvelá vlastnosť, že to nerozbíja proste nič. Do určitej miery. Dobre.
Tak, super. Moc ďakujeme za prezentáciu, bolo to fakt paráda. Tak, máme nejaké otázky tu v publiku? Myslím, že hromadu presne, tak poďme na to. A do mikráku tentokrát, prosím.
Také ľahké.
Ďakujem. Mňa by zaujímalo, že na čo sa tieto networkové EBVF-ka bežne používajú, aký je ten use case?
Asi všetci poznajú Cilium. A vlastne je to spôsob, ako oblbnúť celý ten netstack v Linuxe. Je tam väčšia sloboda. A tam sa... XDP je veľmi primitívny spôsob, respektíve veľmi jednoduchý, nedovolí veľa. Napríklad je to adresa... Ten paket ja nemôžem napríklad modifikovať, zvenčovať, môžem len meniť. To je veľmi jednoduché. Ale viem napríklad riešiť DDoS útoky. Že viem dropovať pakety na základe nejakej analytiky, ktorá príde z kontrolného. Viem napísať security policies pre kontajnery. Vlastne toto robí Cilium. Neviem, či to robí na XDP úrovni. XDP je veľmi zaujímavé, teraz pôjdem trošku do inej sféry. Bare metal. Sú pokusy XDP offloadnúť z mašiny na network interface priamo, čo môže byť veľmi zaujímavý koncept. Netronom spoločnosť to robí proste smartniky, a vlastne celú to, čo sa deje okolo networkingu, offloadu, čo môže byť veľmi podobné tomu, čo dneska robíme s grafickými kartami. Že program dávam niekde do grafické karty. XDP, ako tie smartniky sú, ale to je jedna vec. Ale toto je veľmi tiež zaujímavá oblasť, kde to môže byť prínosom, lebo je to štandard. No a security, toto je networking, ale tie EBPF programy sa dajú písať na kadečo už dneska, na Cisco a teda.
A je to akože rýchlejšie ako nejaké iné alternatívy tým, že to je priamo v Kellneri atačnuté? Alebo...
Nepovedal by som asi, že rýchlejšie. Je to virtuálna mašina, ktorá v tom kerneli beží. Je tam nejaká performance penalty. Čo som videl nejaké štúdie, dokonca keď niekto pozná tieto veci, tak DPDK, čo je nejaký iný spôsob ako bypassnúť network, v určitých veciach bol dokonca performnejší, čo mňa prekvapilo, lebo to je ťahanie do user spaceu a teda. Má to svoje penalty. Ďalšia veľmi dôležitá vec, toto je program, ktorý sa exekuje pre každý paket, čiže nemôže tam človek nejakú business logiku narvať, alebo niečo, ako treba byť v tom opatrný. A ten verifier vás aj preplejská trošku.
OK, ďakujem.
Ja sa chcem spýtať k tomu, čo si vravel, že ťa tam preplejská ten Verify. Vieš tam teda zastaviť nejakú tú trafiku, alebo je tam nejaký timeout na to, aby si ten paket pustil ďalej do istej doby?
Ako nejaký sleep, hej?
V podstate, hej, že či vieš úplne zastaviť tú trafiku, alebo či ten nejaký program, čo to sleduje, ten verifier, jednoducho tam dropne celý ten tvoj program v istom bode, keď nebude poslúchať a...
To urobí verifier. Všetci sa spoliehajú na ten verifier pri loadingu už to nejakým spôsobom. Tam sú dosť také, svojho času to boli dosť prísne obmedzenia. To malo len, že počet inštrukcií, neviem koľko, že ten program nemohol byť veľký. Počet inštrukcií sa dosť teraz zväčšil. Svojho času dokonca také, že for bol celkom problém.
Že cykly tam boli problémy.
Myslím, že teraz už to nie je také až toto...
Hej.
Ale hej, ten verifier bol dosť, je taký dosť, vie byť príjemný.
Jasné. Ďakujem.
OK, ešte niekto v publiku? OK, keď nie, tak ukradneme otázky do slajda. Jo, Linux a Parmor. Ako si to rozumie spolu?
Neviem čítať, počkaj. Ako je riešená bezpečnosť? Nedá sa takto spraviť.
Či vieme nejakým spôsobom, ako takouto záležitosťou hijacknúť trafik a obchádzať firewally a podobné srandy.
No, ale niekto tam musí loadnúť a niekto musí mať tie práva to tam loadnúť a my tomu veríme. Hej. V podstate je to v konečnom dôsledku tak, všade zo security, že je to o traste. Aj Cilium, keď napríklad púšťate ho veľmi agresívnymi právami. Je to zásah do kernelu, čiže no, neviem, niekto by to musel urobiť vedome. Hej. Čiže práve naopak BPF sa často používa ako na riešenie security problémov. Nie je to vec, ktorá to beží zase v user space. To si treba povedať, že to je niečo. Hej, no, keď niekto napíše škodlivý kód a nejako tam loadne a nejako tam atačne na interfejse, tak jasné. Áno. Zdrojové kódy. eBPF, IO stránka, Cilium stránky, oni veľmi dobre všetko dokumentujú. Asi najlepšie proste. Tie zdrojové kódy nie sú nejaké magické, nájdete dokonca, aj keď si dáte GitHub, Cilium, eBPF, čo je vlastne táto knižnica, je tam kopec exemplov na XDP, na Syscalli a teda, čiže ja by som nejak ani svoje nedával, to je zbytočné.
Spústa workshopov tam je tiež.
Áno.
Zaujímavých.
Áno, Isoland má dokonca priamo na eBPF má aj workshop, čiže super. Netreba nejak, že by ja som niečo dával ešte navyše.
Tak a výmácké makrá, čo si používal?
Snippet proste. Dokonca Go, tam mám Vim Go a tie dependency schýbali, preto sa to tak rozbíjalo. Na eBPF nemám žiadny plugin. V podstate, keď som sa s tým hral, je to klasický taký ten C-čko development, hej, že include
a C-text hlavne, že jo.
Čiže tak, neviem, že by bol nejaký dedikovaný ako Vim plugin pre eBPF. Je to vlastne programovanie C-čka. Debugging je tiež zaujímavá téma. To zase debugovanie, keď debugujete kernel, čiže GDB a veci. Je to super téma podľa mňa. Takže tak.
Super. Ešte nejaká otázka náhodou v publiku?
Dobre.
Tak, super.
Tak, som rád.
Ďakujeme.
Jo. OK.
Teraz na kafe a pôjde na ešte ďalšia.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
Oh my God! Each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, Appleware, and container granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness. in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Oh my God, I got each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own superweapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Všetci majú kávičku v sebe. OK. Tak ďalšia prezentácia. Attila Mesároš z Red Hatu nám porozpráva o všetkých možných spôsoboch, akým spôsobom môžeme implementovať Kubernetes operátory. Tak je to tvoje.
Ďakujem. Thank you very much. Hi, welcome everybody. I'm Attila Mesároš, engineer at Red Hat and maintainer of Java Operator SDK. But today I would rather tell you more about all the other ways, or also a little bit of Java Operator SDK, but also the other tools and frameworks which you can use to implement Kubernetes operators, their benefits and limitations, and other factors. But I also want to give you a little bit deeper understanding on some of aspects of Kubernetes operators and the pattern. So this is a Kubernetes meetup, but I still will a little bit define what is an operator. I assume most of you already know. But it's basically, in Kubernetes, you have these built-in types, pods, deployments, config maps, you name it. But you can create your own custom type. This is called custom resources in Kubernetes. And how does it look like? It basically you have to do is create a custom resource definition, which is a built-in type, where you can specify your basic name of your new time, its group, and the other properties that you usually require, like a spec and the status. And in our example, we will use an example to deploy a simple Redis instance. And we require just one input if it by default requires authentication. So Redis is I assume everyone knows, it's a little simple key value store, in-memory key value store. And basically, authentication can be done in a very simple way in Redis, and if this flag will be true, then we set it with an API call. And the status is just if it's ready or not, deployed fully or not, so it's a kind of a simplified version. So after we deploy this or apply this custom resource definition, we can use new custom resources, and basically all the API capabilities of Kubernetes works with these custom resources. You can get them, manipulate them with kubectl, and all the watches, RBAC, and everything applies to them. API server is kind of extended dynamically. So what operator does is just watches these custom resources, checks their spec, which is a spec is basically a desired state, what we want to achieve, and the controllers try to make the actual state of the cluster or other resources closer to these desired states. So that's the idea of this control loop behind operators, but also in general, not just in Kubernetes. So more technically in Kubernetes, what's happening, that we are running this controller, it communicates with the API server, checks these resources, as this very skillful image indicates. So we receive the events, and these events are containing the whole resource. So not just a modification, diff of the resource, but always we receive the whole resource. And in our controller, basically, as a developer of an operator or a controller, we just implement our reconciliation logic. And if something is not in a desired state, we try to create, update either Kubernetes or some external API. So this will be a little bit important for us. So when we are doing some reconciliations, we can usually we are calling Kubernetes APIs, but some of the operators are calling external APIs, like AWS creating an S3 bucket, or just already running pod and accessing your pod's API. In our case, it will be Redis, so we are going to contact Redis from an operator. So that will be kind of a deal for us if some operator is calling external API or just internal APIs in some frameworks. So these controllers are running simple processes or pods in Kubernetes, and basically doesn't really matter in what language, what framework are you implementing the controllers. It's one thing that they want to follow is this operator pattern and some other characteristics that we will touch on, but basically the same principle holds also for the built-in Kubernetes controllers. So in Kubernetes, the deployment controller or stateful controller works exactly the same way. It's a process, communicates with the API, makes changes to the objects or resources through the Kubernetes API. And if you know projects like Crossplane, it's basically all about these external resources. So managing resources on cloud providers and others instead of Terraform or other infrastructure as a code service. I want to talk a little bit more about the communication, how this happens between the controllers and the API server. And there is a component, basically every Kubernetes controller that is on the client side, so on the controller side, that maybe is a little bit hidden for you, for example, in Go. It's informer. So informers are part of the client libraries, like for example, in Go client or Java clients, not part of the operator frameworks. They just use them. And they are responsible to basically properly implement this communication of receiving events from the API server. So not going too much into details, but one of the big points is that it opens the WebSocket, receives the events with the new resources, and stores them in the local cache. This local cache is very important from multiple aspects, but for us, it will be important because you are able to then access the cache locally in the controller. So you won't have to query API server for a fresh state. You just always use local cache on the controller side. And if you receive an event, the informer, you can register an event handler that going to basically handle these events, and you can put there your custom code. So I will show you codes because it's easier to understand how does it work, how does the API, but I'm not going to run it because we don't have simply enough time for that. Trust me, it works mostly. Going to do it in Java, but it's identical basically in Go. What we are doing with informers is creating a client, a Kubernetes client. The client, we can say that we want to, for every Redis instance, in any namespace, have an informer, and the informer, we can set this event handler. And we receive here the events on add, on update, on delete. But basically what at the end happens is we call the reconcile with the new version. In the reconciliations, we don't really work with historical versions. It's a bad pattern in Kubernetes controllers. But theoretically, in informers, you would be able to do that. The old objects comes from the cache, the new is from the new event. So it's simple as this. If you will run this on every change of Redis instance, we will write this simple message to the console. So these are basically informers for us, and there are a little bit more generalized concept in most of the frameworks, but for sure in Java and in Go, it's called event sources or source in controller runtime, which is an abstraction for non-Kubernetes objects. So for the same pattern to have a local cache and watch some or track some other resources outside the cluster, like a state of an RDS instance in Amazon or any other service, event sources is an abstraction for that. So, but the principle or the goal is to follow the same pattern to have a very efficient reconciliations. And how does it look like? It basically, in a controller, we're checking these caches. If the desired state is not there, so some resources we manage, for example, a deployment for our Redis example, then if it's not in the cache, we are going to create it. If it's already in cache, we just compare if the desired state is the same as the cache state. And if it's not the same, we are going to update it. If it's the same, then we are going to just ignore it. So if we are ignoring it, it means that actually no API call made to Kubernetes API. So that's the point. If you have hundreds of thousands of resources and there is nothing to change, we don't make any necessary API toward the Kubernetes. So that's basically the heart in the every Kubernetes controller. So we usually get this question if it's enough to implement informers just for a controller or for an operators. And so in our sample, we will manage 4 resources. So it's actually never one informer or never one event source. We are always tracking all the resources with these informers or event sources. We have always all of them in the local caches, and these are triggering the reconciliations. So we're triggering your logic for every resource. So if a service changes, we will reconcile every resource again. But since others are not changing, and these are on cache, we can make this efficient reconciliation. So there is no API calls, but we are making sure that every resource that we manage are actually the target state. So do we need an operator framework? It's definitely yes. So I would never start with informers, with not even the simplest cases. So there is obviously the concurrency issue. We don't want to have parallel reconciliations, even if the events are coming from multiple sources. If we have one Redis custom resource, there are multiple events coming in. We don't want to reconcile them in concurrently. We want to have just only one reconciliation for one custom resource. Of course, concurrently running the other custom resources, but not for that one. So generally, these operator frameworks are already modeling this domain very nicely. They have these all kind of capabilities for metrics, finalizers, rate limiting, error handling. There's a huge list that makes sense to work in an operator framework level, not on some informers. But informers are still, and these caches are the heart of these controllers. So I will name these two major, the Go stack and Java stack. Usually we have these clients, both for Java we use in Java Operator SDK Fabricate client, and Java Operator SDK implements this controller runtime where inside of the SDK, which is basically about the framework to make your operators and all the necessary components. And we support in Java Quarkus and Spring, and also have a plugin for Go Operator SDK, the scaffold projects. Same happens or very similar in Go, that there is a control runtime, which is a core library, and QBuilder Operator SDK brings additional facilities. But Operator SDK also supports these two additional ways to implement operators, the Helm and Ansible. So just to give you a notion again about the complexity, how hard it is to implement, for example, this Redis that will manage these four resources, deployment, a service for the deployment, and the secret, which will contain a password for Redis, and setting up this and reconciling. I will show you an example in Java quickly. So in Java, it's really, you have to ignore everything. You can ignore everything from these four classes, and from these four classes, this is in Quarkus, not pure Java, but font bigger. I'm not sure. Where is that? Not using this. Where is that? Sorry, not really.
You can go presentation mode. Yeah.
View, experience, and presentation mode. Yeah. Okay. Now I don't know if. Okay, so we have these three classes: the custom resource. Some of them just implement the custom resource, and then we have the reconciler, which is basically the only class you have to implement with two interfaces. And one is the event source initializer will provide you these informers. So we say that we are going to watch the secret, deployment, and service. And that's it. Basically, this is a registration of these informers. And then we have a simple logic in Java to reconcile these resources. So we reconcile deployment, service, and we wait until the deployment is ready. In the spec is required authentication, then we reconcile out of the secret, we create if it's not there, and set the password in Redis. So setting the password in Redis is just calling the API with the Redis client and setting the password basically with require press command. And generically, the reconciliation is same for every of these resources. It's a little bit simplified version. We say that we create this deployment if it's not exist. And basically, usually that's happening like with just using a template where we are filling the missing field. So in our case, we fill the name and namespace, but there is already an image and predefined, and it's running Redis in memory mode. So basically, that's it. So how do I exit presentation mode? Basically, it's just to give you sorry. So basically, that's it. So this is as you can see, it's not really that complex to implement this logic. So using these generic frameworks is definitely a very safe choice. You won't hit anymore. It covers absolutely all use cases. But if you are not a developer or you are more the platform side, it might be harder you to start with. So you need to really proficient in the language, and not all languages have these major operator frameworks. So we will a little bit take in now on other alternatives, and which are on market. There is not much more. We will start with Metacontroller, which is a very interesting concept, comes from Google. And this is another basic way to just not use a generic framework, but use a kind of a different, and that basically catches it from different aspect. It says that we have this generic controller, it's called Metacontroller, and we can configure it with Metacontroller configuration resources. And how does it work is that basically you can you set up these watches or informers, and Metacontroller will make an HTTP request instead of calling the reconciliation in a code. But basically, it makes an HTTP request with all the resources, with the parent, the Redis instance, the secret, deployment, to a web service endpoint. And what you have to do is return the target state. So the target deployment, the service, or the secret. And Metacontroller will do all the communication with the Kubernetes API. So this is interesting from a perspective that you don't have, it's not bound to any language. You can implement this interface in any language you like. Maybe that language doesn't have a full-blown operator framework. So this is basically kind of the big plus of this approach is language independent. So just give you, again, a little bit look on the code. So it's at the end very similar that you would implement in a generic in Java. You just receive you are accessing the caches not through APIs, but you are accessing the resources from the request. So we have the request which contains the Redis instance, and here are the children, basically a map of all resources, all the deployments, and the resources that we manage. And we are doing the same. Actually, we can do it the same to set the password if the deployment is ready. This endpoint will again code on every change of these resources. So Metacontroller watches these resources, and all we have to do is return the desired state of these deployments and services, and maybe set some status that we also return in the response. So actually, the complexity of this implementation is very similar to the one with the generic frameworks. Just to give you a look also on this, how it's how you are configuring it. All you have to do in our example is just say that I have a parent resource, which is the Redis instance, and I have these 3 child resources, a service, secret, and deployment, and the URL what to call. And basically, automagically, everything works from this point to you. And what you have to do is just deploy this Metacontroller and deploy this or apply this configuration, and it will call this endpoint. So what are the problems with this? The one is that they are explicitly stating in the docs that if you are a controller which watches every resource on a cluster, like every pod or every config mess, this request can be very huge. So it's not really fitting that use case. And in my opinion, at least, it doesn't really fit for the use case when you are managing these external resources. So when you are not managing Kubernetes resources, there is no way to tell Metacontroller that you are watching resources outside of the cluster, which is definitely possible with the generic frameworks. So it kind of has this limitation that you can hack it, you can call the API of Redis, but doesn't have these event sources. You cannot tell that trigger the reconciliation when there is we are managing an external resource, not a Kubernetes resource. And there are some other limitations. We cannot manage cross namespace references. Like if you have Redis instance in namespace A, I want to have the deployment in namespace B, then this is not possible. So there are these other minor limitations. But otherwise, it's one other way to go and maybe good to start with. There is another way. It's called Helm operators. And Helm operators, the name is, it's create a bridge between custom resources and Helm, or operators and Helm. Probably all of you know Helm, right? Is there someone who doesn't? Okay, so it's basically what does, it maps the spec of the custom resource to the values of a Helm operator. So just give you a little insight. All I had to do here, just very quickly, is to put the required authentication in the values of Helm, and then this can be used in a Helm chart, as you normally do, and basically don't create a secret if this is false. But basically, this will generate you a binary or an image, and you can deploy it, and it at the end maps the value from the spec to this values, the Helm chart, and execute and apply the Helm chart. It does this very efficiently. There is lots of magic with the caches working in the background. So it really becomes a very kind of optimized way to managing this Helm chart. On the other hand, it's just powerful as a Helm chart. So it just can work with Kubernetes objects. Helm charts just can use these values from the spec. So in compared with Metacontroller, it's really much less powerful in the sense that when you're doing reconciliation in Metacontroller, you are having all the related resources, child resources, deployment, and you can make decisions based on that. You have that available in a generic programming language. In Helm, you are still using this, you are just using the custom resource spec, nothing else, and based on that, you're generating the resources using a Helm chart. So who is this for? To be honest, what I could imagine is if you have a service, this is a very simple deployment, you want to give this experience, providing an operator for your service, you can set up this within minutes and generate an operator and provide that an operator hub. And if your service would require a little bit more complex operator, you just replace the controller. So if you don't want to work with Helm charts, you want to have the operators, it's a way to replace that or basically just use it instead of that. But otherwise, it's not really more powerful than a Helm charts, other than it manages these watches out of the box for you for every resource. So you can configure that, but here you have the basically a watches YAML event. This can be configured how the watches and informers works, but by default, it creates informer for every resource that you create with the Helm chart. So that part is at least very efficient. Okay, and the last one is Ansible. So Operator SDK provides also a bridge between Ansible and basic operators. And how does it work? It's also a very similar concept to Helm, it's just with Ansible. So there is a project generated for you, and all I had to do to implement this example is just to implement this tasks file in Ansible. Although I was working with Ansible first time in the life, so it might be not that efficient, or some Ansible magician can do this better. But Ansible has support for Kubernetes resources. So you can very easily just template this. You can use the resources from the variables from the spec in these Ansible operators and manage these resources. A little bit more problem was with the Redis part, but obviously there is also Redis support in Ansible, so I had to use this general Redis module and set the password from the secret. On the other hand, I had to fetch the Kubernetes resource and get it to some state, set the fact, basically the secret, and this will use, I guess, I think the cache, so it doesn't really go direct to the Kubernetes, but it's a little bit, can be cumbersome to manage these resources with Ansible. On the other hand, but you can define watches and same like this, and it works in a smart way that you handle watches and finalize and caches, uses caches if it can, and there are metrics, finalizers supported, and it's really kind of a feature complete as it can be regarding to Ansible. So who is this for, basically? So as a Java developer or Go developer, I wouldn't probably start writing operator in Ansible. But if you are kind of expert on this Ansible, then this might be a choice, and you have an operator that really fits this use case. Although it sometimes can be hard to tell, but it's therefore you can use it. It's if you are an expert in Ansible, probably this is a lower barrier to start and create an operator than from scratch in generic programming language. And operator SDK documentation states that Ansible operators, of course, are as powerful as Go or Java or any generic programming language operator, although maybe the optimization, performance, or expressiveness, it's maybe even, might feel even hackier, but not, I guess, not all the cases. And there are few exceptions or few corner cases when it won't work. Simply, it's not enough to cover. They are explicitly stating also that. Okay, so basically, this is mostly I wanted to say on this talk, and I guess we have a little bit more space for questions. Yeah, thank you very much.
Okay, thank you very much for the presentation. And I'll check the Slido. And yeah, no questions online. Anyone here in the audience want to ask something?
Any questions about operators or about these frameworks, please?
Yeah, one. Yeah, how do you implement complex logics for a custom resource Ansible operator?
Yeah, that's a good question, and maybe I'm not the best person to. This is also basically an Ansible question generally. So in the same way as you would do it in Ansible. So for example, based on the CR, so you have this require authentication, all the inputs from the CR there for you. So you, for example, I'm creating the secret only if the required authentication is true. So you can use just these Ansible idioms and structures and access all the information or input from a custom resource spec. And then basically just have these tasks based on that and have it in the Ansible way. I can imagine this can be problematic in some cases.
Primarily, what is the problem? Ansible is a declarative language, so you just program what do you want and you don't care how you will do it. So theoretically you have to create some plugin for Ansible if you want some custom logic flags, and this is a little weird because theoretically I can program it directly in the Golang. So it doesn't make sense for me use Ansible for full operator with very hard logic.
Yes, with very hard, yes. So it's, but also there is, you don't have to code most of it. So these external APIs, there are already modules for Ansible there. So you can just reuse them, and for Redis, I found this, it's part of the core, some general community module. So you can just reuse those modules and you don't have to think about on those. If there is something you want to, for example, check if the password already exists, and do this idempotent in all cases, the idempotency might be a problem actually. But otherwise, there are the modules for you. And I don't know, I'm not sure how this with Ansible in all cases with idempotency. I think it's not always idempotent. At least the Redis wasn't. But it's not really. I'm not sure if this can be actually made idempotent. This one operation, our module.
Yeah, we have another question on the Slido. Whether users are expected to write custom resource definition in YAML.
I think there is expected that you write them. So in Java and Go, you are generated from source code, or in Java we have other way around that we generate source code from CRDs if you prefer contract first. But it generates you a very generic CRD, and then as far as I know, there is no way to nicely do it and generate it from the code. And basically, there is no information in Ansible how to basically generate that, or it will be extremely hard.
Okay, and the next one, what do we need to consider in order to choose best programming language for an operator?
I think you have to first choose your programming language when you can code. But if you can code in more programming languages very nicely, then probably the maturity of the frameworks I would choose. So if but for example, we could do a comparison between Java and Go, and there is almost nothing that would miss in Java. And actually, in Java Operator SDK, we have features which are not in Go. Because simply Go has this actually multiple. So Go has this philosophy to keep it simple as possible. For example, we have high-level abstractions in Java Operator SDK. We have something like dynamically changing following namespaces, or which are checked namespaces. If you don't check the whole cluster, but some namespaces only, and things like that. So the maturity is probably the leading. And to be honest, I think there are some for Rust. Python seems to be very mature, and Java and Go, of course. I don't know. There are some others, like there is also TypeScript or Node or other languages, but I won't judge them here. Yeah, you have to do that.
We're gonna hear Python in a minute. Yeah, another question. Whether it's a metal operator like a SPOF?
Is a metal operator single point? Is a single point of failure. So in generally, this is a problem in Kubernetes. So Kubernetes operators, if operators stop working, then our Kubernetes stops working. So, but if we deploy operators at deployment, the pod stops, it's restarted. And the whole design of these operators and basically these informers, one of the reasons why there are those caches, is if it starts again, actually in this case not, but so if it starts again, it reconciles all the resources. So basically this is built in the architecture and the setup that operator will stop, they will fail, we will deploy new versions, and but it will basically, it's very resilient. And also these connections with these watches are fails. Actually, here, the informer will every 5 to 10 minutes close the connection and reopen because of a bug there in Kubernetes. So but it's basically designed this way to be resilient.
Okay, and the last question, a bit more funny. Who likes to write operators? Do you like writing operators in Kubernetes?
Okay, do you like writing, or do you like the pattern?
I don't know what was the intention, but probably the writing. I'm mainly, what we used to say, we mainly implement the operator framework, so I like writing operator frameworks.
and I can do that, I can say. And we are in contact basically with multiple teams like the Flink operator, which is kind of market lead, and Keycloak and other operators which are implementing that and helping. Hey, I think it's fun. And in Java we have this high-level abstraction which makes it much easier to write these operators. I did not discuss it here in this talk, but there are lots of problems we can generalize in libraries, and we support that. So it's actually, you don't have to write from scratch these reconciliations and stuff. So it's much easier with high-level library. That's kind of what's in Java, and I think you usually do it anyway when you write complex operators and multiple like in cross-plane. So it's not like you write everything from scratch all the time. This logic around it, you have usually the high-level abstractions. But yeah, I think it's fun.
Okay, thank you. We're out of time, so if we have any questions in the audience, you can just pass them those Slido and we can answer them later.
Yeah, or stop me anywhere.
or just stop and just grab Attila somewhere out there. Okay, thank you very much.
Thank you.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Oh my God.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, Appleware, and container granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Tak jo, môžeme? Tak paráda. Pokračujeme ďalšou prednáškou. Máme trošičku zmenu v programe oproti tomu, čo je v slajdu. Máme prehodeného Vieroša s Davidom, takže teraz nám príde David porozprávať o Arclowne. Tak je to tvoje.
Veľmi pekne. Ahojte, ja som David a trošku o mne. Bežíme Kubernetesy od 2017 spolu s tímom a riešili sme ešte vtedy 5 sety, ak si to niekto pamätá. To bolo také trošku dostrápenie. A pracujeme hlavne v IoT a Energy doméne ako Blueprint Power na IoT projektoch, kde to vyzerá celkom zaujímavo, lebo potrebujeme spájať cloud s nejakými on-premise riešeniami. A ešte som nikdy nebudoval nejaký on-premise solution priamo, takže že by som mal nejaké skúsenosti s VM-kami a teraz serverami a nasadzovaním a prevádzkovaním tohto. A som nejakým pravidelným participantom tu na týchto bratislavských cloud meetupoch, takže ak by ste niekedy chceli pokecať, väčšinou som tam, takže vieme sa niekedy stretnúť aj neskôršie. A čo sa týka témy, ktorú mám, budem prezentovať Arclone Storage ako jeden z optionov, ktorou sa dá jednoducho vyriešiť zo pár problémov, ktoré sú pri prevádzke rôznych aplikácií. Väčšinou to vznikne s tým, že máme nejaký monolit alebo máme nejakú staršiu aplikáciu, ktorá nie je úplne fine-tuned na to, aby bola pekne nasadená a používala objekty, ktoré nám poskytujú cloudy. Typický príklad môže byť napríklad, ak poznáte keycloak od Red Hatu, niekedy nejaké certifikáty, ktoré on potrebuje na presnom mieste, alebo nejaké jarko, alebo niečo také, podsunúť mu ako tému. To môže byť jeden z takých tých klasických vecí. Druhé, pokiaľ nechcem za Amazon, napríklad CloudFronty, platiť veľa, viem to použiť aj na nejaké jednoduché CDN-ko. Je tu rôzne metodiky, ako sa to dá aplikovať a ten Arclone je docela všeobecný na to, aby sme si ukázali, že ako to vyzerá v praxi. Nebudem mať veľa teórie, ja radšej to ukážem live, ako to funguje, takže rovno hovorím ako prefix, možno nejaké veci sa pokazia, ale vtedy to je viacej srandovné a viacej záživné. A prejdeme si s tým, že čo všetko by sa vlastne dalo s tým Arclonom spraviť. Aby som nemusel opisovať do prezentácie to, že čo všetko ten Arclone vie a ako vie, tak jedna z jednoduchých ukážok, ktoré to vie spraviť, je v rámci týchto features, ktoré tu môžete vidieť, má podľa mňa jednu z najväčších výhod, že nemusím si implementovať nejaký intermittent transfer, keď mám nejaké S3 integráciu v rámci jazykov, to znamená, či to je Python, či to je Java alebo niečo také. Hej. Typický botov od AWS tiež má problém a treba si to riešiť sám, aby som si nejako rezumol väčší large, ktorý by som downloadoval. Ten Arclone veľakrát je prirovnávaný k tomu, ako máme rsynky, ak Linuxáci ešte si pamätajú. A je to vlastne na object storage. V rámci tých objectových storageov nemajú ich málo, to znamená, že je tu celkom hodne dosť veľa vecí, na ktoré sa to dá použiť. A keď máte nejaké projekty, ktoré napríklad nepoužívajú iba pekné AWS, ktoré má konzulu, ale napríklad aj lokálneho providera, ktorý má iba tiketový supportový systém, tak dá sa to vlastne napasovať aj na takéto objektové storage, ktoré sú tam. V tom probléme, ktorý tam je tiež ďalší, že tie updaty, ktoré sa robia takto cez tento systém, nemusíme potom potrebovať na to inžiniera. Znamená, že pokiaľ si ja viem pripraviť nejaký S3 bucket, ktorý môžem fungovať ako rozhranie a viem to dať niekomu inému, tak nie je potrebné kontaktovať DevOps support alebo nejaký SRE team na to, aby sme dostali niečo do produkcie, lebo vieme sa dohodnúť na tom, že OK, tak cieľovým hľadiskom je nejaký bucket, do ktorého to fúkneme. Aby som sa teda dostal k tomu, že v rámci tohto problému, ako to vyzerá, keby sme išli na nejaký solution, tak v tom solutione môžeme si to povedať tak, že OK, tak máme nejaký R-klon, ktorý vie robiť veľa vecí a ako by sme to vedeli aplikovať. Sú také dva najbežnejšie praktické prípady, ktoré sme využívali u nás. Prvý je, OK, tak mám nejaký sidecar, ktorý viem konštantne robiť a podávať tieto fajly k tým workloadom. V rámci toho sidecaru nie je tam žiadna raketová veda. Mám nejaký bucket, mám nejaký storage, do ktorého si to fúknem. Používame MTDIRy medzi tým a nakonfigurujeme to tak, aby nám vlastne pravidelne synkoval alebo downloadoval na nejaký cron job, na niečo, aby sme sa dostali k tomu. A druhá stránka veci je napríklad init container. V tých sidecaroch predsa len nedostaneme ten blocking, že sa nám spustí workload predtým, než by mal tie fajly mať k dispozícii. A na ten init container vieme aj nejaké väčšie datadumpy pripraviť, počkať, kým sa to stiahne a potom si ten workload spustíme. Okrem týchto je tam ešte jedna výhoda toho R-klonu a to je to, že aj on samotný poskytuje nejaké web GUIčko, s ktorým dá sa nejako pracovať. Nie je to úplne ideálny experience, však ukážem, ale dá sa naučiť vlastne aj ľudí, ktorí pri pojmu S3 bucket nebudú presne tušiť, že čo to je, ale vedia, kam to majú uložiť v rámci toho fajlu. A okrem tohto, ďalší taký typický, keď som to tak mohol nazvať, že Pursman CDN, ktoré vlastne vieme spraviť tak, že spojíme to s Nginxom, vieme na to dať vlastne, vie to poskytovať veľké fajly, vie to škálovať ako potrebuje, lebo je to predsa len že jednoduchý stateless poskytovateľ. Je tam continuous sync, takže ako nám prichádzajú do takéhoto CDN-ka nové a nové veci, dohrá sa to dokopy a dokonca si to vieme aj spárovať, taký viacej advanced topic. Nginx vie komunikovať pomocou nejakých OAuth zaklinadiel na OAuth proxy, takže tá statika sa dá vlastne zabezpečiť. To znamená, že napríklad máme frontend, ktorý beží cez OpenID OAuth, používa bearer tokeny a JVTčka na komunikáciu. A teraz nechceme statiku vystaviť len tak a referer v API headroch väčšinou sa nie je niečo, čo by sa dalo považovať za úplnú security, tak sa to vlastne dá nahrávať dokopy do toho. Keby som teraz mal prejsť na nejaký live demo, ktoré mám pripravené, tak bude to vyzerať následovne. Ja mám na Google v Cloud Storage nejaký example, ktorý som si pripravil práve teraz a sú tam nahraté iba fotky, hej, nejaký pes, nejaké takéto srandy, aby sme si vedeli ukázať, že jo, funguje to. Okrem toho mám vlastne rozbehaný aj ten R-klon. V rámci toho R-klonu si ukážeme, ako tie konfigy fungujú. A potom samotné Helm chart nasadenie klasického workloadu s tým, že vlastne máme to tam spojaznené ako sidecar. Takže prvé nejaké veci, ktoré tam sú v tejto dashboarde toho R-klonu, sú nejaké konfigy, kde keby som si aj išiel vytvárať nový konfig, tak tu sú tí providery, ktorí oni mali vylistované na stránke. A podľa toho sa to rozbehne do rôznych konfiguračných optionov, ktoré tam sú, je treba podhodiť. Oveľa jednoduchšie je rovno to tam nakonfigurovať aj s nejakými fajlami. Toto je samozrejme live example. Nie je to niečo, čo by som akože povedal ako production usage. Ale R-klon podporuje ešte ďalšiu takú peknú feature. Dá sa toto celé hodiť rovno do environment variables. Takže nie je potrebný žiaden file, nie je potrebné to niekam dávať do nejakého konfu, študovať teraz nejakú mágiu, aký formát vlastne toho konfu by potreboval. Majú prefixové variables, ktoré sa dajú potom upraviť. Takže keď teraz prejdem do kódu ako takého, neviem, že či to vidíte dostatočne veľké, alebo dám to ešte väčšie. Dobre. Tak to by mohlo byť lepšie. Tak v rámci toho kódu my sme vlastne pripravili niečo ako veľmi simple static server. Tento veľmi simple static server vlastne funguje tak, že na pozadí primárne spúšťa Nginx a ako sidecar má vlastne tento R-klon. V nejakých tých konfiguračných hodnotách, ku ktorým sa môžeme dostať, také typické vlastne veci, ktoré tam sú, je Nginx, veľmi best practice označený latest, prosím, berte ako demo. A okrem toho vlastne je tam potom nakonfigurovaný nejaký ingress, keby sme potrebovali. Tam ešte prejdem k nejakému security. A tento data provider. Tá zložitosť alebo rýchlosť toho CDNK, ako ho viem pripraviť, je vyslovene iba zo pár environment variables, ktoré potrebujem mať, ak už mám teda samozrejme nejaký systém account a mám ten JSON aj od toho providera, voči ktorému sa viem validovať. To znamená, že viem si označiť ten presné označenie toho, že cez akého providera idem, odkiaľ kam a on mi to len stiahne a synkne potom na tom boote. Tieto všetky konfigy nie je tam ešte tá autentifikácia. My interne, neviem, či poznáte, používame SOPSy, je to od Mozily, veľmi, veľmi pekná vec. Dajú sa security commitnúť do Gitu, viem, to môže byť taký trošku vnímané ako heresy, ale sú zašifrované. To znamená, že viem sa vlastne dostať do toho, že pomocou tých SOPSov mám zašifrované jednotlivé tie fajly a nebudete ich vidieť. Také typické šifrovanie, ako by to vlastne mohlo vyzerať, ukážem rovno live. Je veľmi pekné. Lebo teraz som vlastne zašifroval in place ten celý file. Teraz si to dovolím aj odprezentovať, lebo nebol som si istý, či som to predtým dešifroval, jak som sa pripravoval na prednášku. Takže teraz môžete vlastne vidieť na tejto strane, keď dám preč aj tohto srandistu. Mám tu nejaký service account, kde sú všetky tie dôležité veci, ktoré Google po nás požaduje na to, aby sme sa mohli nejako autentifikovať voči nemu. A je to klasicky normálne AS256 zašifrovaná. Toto celé existuje takisto aj v SOPSový plugin do Helmu. To znamená, že nemusím ja si manuálne to pretavovať, raz to nastavím a odvtedy to viem vlastne pekne používať a viem sa aj pozerať na zmeny. Okrem samozrejme tohto potrebujeme aj nejaký Nginx config, aby sme vedeli takéto nejaké CDN-ko vlastne prevádzkovať. V tomto Nginx configu rozdeľujem vlastne dve veci a ja som to tu aj uviedol a to je hlavne ten private časť, ktorá by mala byť akože protected povedzme nejakým tým OAuth-ovým JVT-čkom a potom nejaká public časť, ktorú budeme vedieť servovať. Na to, aby sme vlastne vedeli ten protected vystaviť, je potrebné mať niečo, čo vie komunikovať cez ten OpenID protokol. Takže bavíme sa o tom, že keby sme išli do toho advanced caseu, tak potrebujem yet another sidecar, ktorý by mi poskytoval iba túto funkčnosť a vie komunikovať napríklad s tým keycloakom, alebo to viem rovno integrovať do Google. To znamená, že vedia vlastne, keby to bolo nejaké interaktívne CDN-ko, Nginx poskytuje akože výpis DIRu, cez ktorý sa viem klikať, aj tak by som si to vedel zabezpečiť, kam by sa to mohlo dostať. Táto komunikácia, ktorú môžete vidieť tunak, je vyslovene na to. To znamená, že Nginxu príde request, ktorý je bez bearer tokenu a presmeruje ho na to, aby sa cez OAuth proxy a cez OpenID flow dostal k tomu, že ten bearer mu nakoniec dojde. Druhá stránka, toto je vlastne ten location, ktorý už je na ten secure, kde môžete vidieť jednotlivé vyžadovanie toho, že aby sme boli autentifikovaní cez ten OAuth. A okrem tohto už len nejaké klasické zaklinadlá od Nginxu, ktoré sú na to, aby sme to CDN-ko vedeli nejako efektívne poskytovať. Keď sa pozriete sem, tak tieto jednotlivé konfiguráky nemajú nič ešte s nejakou security alebo nejakým zabezpečením toho Nginxu. To je kvôli tomu, lebo to je ten workload, to je kontajner, v ktorom bežíme vnútri v rámci toho podu. Keby sme to chceli vystaviť do sveta, tak to bola vlastne tá konfigurácia toho ingresu, kde sa teraz vrátim, kde sme my tiež po nejakých skenoch a po nejakých evaluáciách v rámci toho security prišli na to, že nejaké potrebné headre tam sú. Keď sa k tomu dostanem. Aha. Dobre. Mýkajú to. Takže tu môžete vidieť ten naive out. Hej. To znamená, že nejaké veci, ktoré sú na to, aby som zabránil klasickému discovery a nejakým zisťovaniam toho, že OK, tak o čo ide. A kompresia v CDN-ku nejaká taká celkom dosť potrebná. Samozrejme caching, bez toho to nejde. A potom nejaké referer policy, X content, X protections, klasiky, ktoré cez security headers sú na to skenery, Mozilla Observatory a tak ďalej, vedia povedať, akým smerom sa vybrať na to, aby sme vlastne to vedeli zabezpečiť ako samotné CDN-ko. Tieto veci pridávame až na forme toho ingresu ako takého. Interne my máme tiež takú politiku, že používame vlastne MTLS medzi jednotlivými funkciami, ale nechcel som spraviť toto demo ešte zložitejšie, ale viem aspoň ukázať akože ten avenue, ktorým by to šlo. A my používame interne cert manažera na to, aby sme fungovali cez Let's Encrypty, to si nemyslím, že je tiež nejaká úplná novinka. A na to MTLS-ko vo vnútri, keďže ten Let's Encrypt vyžaduje pravidelné obnovovanie, tak to nie je úplne ideálne, ale dá sa to spraviť cez HashiCorp Vault. Ak ho poznáte, tiež vie spraviť PKI inštanciu, normálne certifikačnú autoritu a potom spraviť normálne jednoducho cez Console Templates iba vydávanie certifikátov pre každý a jeden workload, ktorý tam je. Je to trošku efektívnejšie fungovanie toho MTLS-ka, ako keď sme to vyhodnocovali, to mohlo byť nejakého 2018-2019, sme sa bavili o service meshoch, napríklad Linkerd alebo niečo iné. Väčšinou prichádzalo s tým, že bol nejaký akože performance hit na úrovni, don't quote me on this, 20%, takže čo bolo akože to zníženie toho workloadu, nakoľko sme bežali. Aby sme sa teraz dostali aj k tomu, že ako to vlastne vyzerá, keď to beží, tak poďme sa na to pozrieť. Zase sa opýtam, asi bude treba trošku väčšie. Dobre. Mám ten Helm chart nasadený a v rámci toho mám replikáciu na klasicky normálne 3 pody. V tých 3 podoch mi bežia dva kontajnery. No surprise, jeden z toho je Nginx, druhý je vlastne Arclone. V rámci toho Arcloneu vlastne bežím na takej funkcii, že mám nejaké data. Keby som sa na to pozrel, tak to, čo som mal nahraté v tom buckete, tak tam sú vlastne synchronizované tie jednotlivé fajly. Aby sme si ukázali aj, ako vlastne tá synchronizácia funguje, tak keď sa pozrieme na to cez tú definíciu toho jednotlivého podu, dajte mi sekundu, tak toto je vlastne nejaký skript, ktorý sa dá rovno ad hoc podhodiť a nemusíme k tomu spísať nejaký ďalší, aby sme balíčkovali to dovnútra, do toho kontajnera. Keď to len tak jednoducho vysvetlím, pokiaľ by mi akože mal som nejaké PID toho Arclone syncu, tak to tam nie je a keď spustím, tak vlastne to synkne ten remote. Tu môžete vidieť nejaké konfiguráky, ktoré viem podhodiť v rámci toho chartu. To znamená, že pokiaľ nejaký workload to vyžaduje na špecifickej úrovni, nie je lomeno data alebo lomeno www, lomeno html, nejaké takéto príklady, ako z tohto CDN-ka, tak si to viem pekne nakonfigurovať, aby mi to vlastne tam synklo. Okrem tohto, my tu používame ešte aj crontaby. Dalo by sa to bežať akože na full sync móde, to znamená, že vytvoriť z toho démona a nechať to žiť a nechať to dotazovať. A popravde, my sme sa nevybrali týmto riešením, ale povedali sme si, že bude stačiť nejaký kronový vlastne interval, predsa len akože na tom CDN-ku, aspoň v našom prípade to nie je také, že sa potrebujeme dostať na sekundovú synchronizáciu alebo menej. Aby nám to nevyhovovalo. A šetrí to aj trošku vlastne palivo v rámci toho, že koľko API callov to vyžaduje a koľko synkov tam vlastne príde medzi tým. Keď sa na to pozriem z toho druhej stránky, to znamená, že teraz ide o to prepojenie medzi týmito dvoma sidecarmi, tak to funguje cez MTDIR. MTDIR je veľmi jednoduchá inštancia v Kubernetesoch, kedy vlastne počas života celého podu ten MTDIR je nejako alokovaný v rámci toho nodu a vie byť zdieľaný vo všetkých kontajneroch. A je tam asi jeden dôležité upozornenie. Pri reštarte jednotlivých kontajnerov ten MTDIR nie je wipenutý. To znamená, že naivná aplikácia, ktorá by si mohla myslieť, že za každým dostane prázdny priestor, tak môže crashnúť na tom, že OO file existuje. A z tohto pohľadu vlastne treba rátať tak, že až keď by som zabil celý ten pod, tak vtedy sa mi to premaže a až vtedy sa mi to dotiahne. Okrem tohto, tu už nie je teda žiadna veľká mágia, ale máme ako môžete vidieť tunak, na tom istom mieste má outnutý vlastne ten spoločný file, z ktorého sa viem na to dostať. No a teraz, aby som vlastne ešte vedel ukázať, že naozaj to funguje, a čeknem najprv, že či mám vlastne port forward. Môžeme dať niečo na tento štýl. Keď sa k tomu dostanem, tu môžete vidieť môj predošlý test. Yes. Takže viem sa dostať na to cez jednoduchý perfordat. Keď to vystavím potom cez ingresy, tak viem sa k tomu priblížiť. Keby som išiel teraz manipulovať s tým, že OK, tak chcem tu dostať niečo iné, tak napríklad môžem si vybrať nejaký ďalší file, ktorý by som si stiahol. Máme nejakú databanku nejakých takýchto obrázkov, cez ktoré sa to dá vlastne poskytovať. A viem to potom nahrať donútra. To znamená, že aj toto môže byť interfejs pre niekoho cez IAMI veľmi pekne nastaviteľný a nechať im ukázať, takto sa dajú dostávať nové veci. Typicky je to, keď potrebujeme využívať nejaké nové obrázky pri onboardingu nových zákazníkov, nových deviceov, referenciu nejakých ikoniek a tak ďalej, ktoré nie sú dynamicky poskytované na tým frontendom. Čo sa týka tohto, tak tam môžem skúsiť nahrať vlastne znova jeden. Aha. Dobre, tak to môžem ukázať aj cez tohto, aby som to nahral niekam inom. Áno, to sú boli všetko testy. No, takže to, čo som rozprával o tom, že je to interfejs trošku hranatý, tak všetky tieto veci ste mohli teraz vidieť. Nie je to úplne live, nezobrazilo sa mi to tam, nie je tam ten feedback. Ale ako Pursman Choice a na to, že to vie poskytovať cez tých 40 data providerov. Not bad. No a teraz vlastne z toho, ako sa to dostalo tam, k príchode toho data provideru, on sa vlastne dostane k tomu, že za nejakú ekvivalentnú chvíľku sa tam vlastne dotiahne pomocou toho kronu vlastne ten jednotlivý sync. To znamená, že teraz ho tam ešte není, je tam nejaká kadencia, počas ktorých to je nastavené a myslím si, že to bolo na nejakých 5 minút alebo niečo také, aby sa nám to dotiahlo, takže môžem to potom neskôršie ukázať, ako vlastne cez toto bežíme. Okrem tohto, v rámci tých values a to, čo sa nám osvedčilo ešte pre ten OAuth proxy, ako taký, vedie tam poskytovať viacerých JVT providerov. To znamená, že typický príklad môže byť jednotliví klienti. Ak poznáte OpenID a OAuth trošku bližšie, tak vždycky sa vlastne v rámci toho flowu na to JVT pýtame voči nejakému konkrétnemu klientovi, aby nám vydal ten token. A môže sa nastať taký prípad, že potrebujem si čeknúť, čo na tom CDN-ku mám. Ale nechcem teraz ísť cez ten úplný flow toho, ako jednotlivá tá aplikácia beží. Takže vieme to spraviť tak, že ak používate interne vlastne napríklad keyclov ako management na internal users, tak sa dajú pridať dvaja, traja, viacero klientov do toho outproxy na to, aby jednak tá aplikácia fungovala a jednak, aby sme dostali tú autentifikáciu aj od toho, keď sa človek len prihlási. To znamená, že vytočím tú stránku, hodím ma to na default login flow, cez ktorý sa interný používateľ vie prihlásiť, ale ako ďalších optional a vlastne JVT verifierov vieme selektnúť aj potom ďalšie aplikácie. Tu by som asi teraz ešte zastavil, možno nejaký taký akože hands of show, čo sa týka R-klónu, že či som nejako, že priniesol nejaké novšie informácie. Koľko ti poznáte R-klón, alebo ste ho aktívne používali? Alright, nice. Dobre, tak to je aspoň dobrý pointer, že je to akože cool vec. Ja som na to prišiel tiež tak sám, že mám doma homelab a potreboval som namiesto R-syncov niečo fúknuť do S3 trojky a zrazu som mal hlavu smutku, že ako to robiť, lebo človeku sa nechce vyťahovať Python a teraz robiť to všetko na to, aby som si mal nejaký skript. Takže tento R-klón ako osveta, myslím si, že to je veľmi, veľmi zaujímavá vec, ktorá sa dá docela jednoducho použiť. Ešte majú aj GUIčku k tomu, takže netreba sa trápiť s nejakými extra zaklinadlami v rámci tých konfov, tak to je veľmi pekné. Dobre, myslím si, že máme aj v rámci tej prezentácie ako. Ak by ste mali nejaké otázky, happy to answer v rámci tohto riešenia.
tak teda ešte raz, že by ma zaujímalo, že prečo ste sa rozhodli s touto cestou, lebo nakonfigurovať ten Nginx voči nejakému originu, aby to cacheoval ten content, nie je až také zložité. A toto by som videl dosť veľký problém, keby si mal, povedzme, ten origin napríklad 300 gigový, hej, že proste obrovský. Takže pri každom štartovaní by si musel klonovať celý vlastne ten repozitár.
Jasné. Toto bolo vlastne náš first avenue, kde vtedy, keby sme sa dostali do toho, že to je tento 300 gigový, tak vieme to vlastne spraviť tak, že vieme to držať normálne na storage klase, ktorá nám to vie poskytnúť. Hej. To znamená, že to je ešte vec, ktorú som nepovedal, a ďakujem veľmi pekne. Argon funguje ako rsync, to znamená, že ak nájdete fajly, ktoré tam sú, tak on spraví diff a vie si stiahnuť iba rozdiel. To je tá nice to have feature. Hej. To znamená, že pokiaľ sa bežím na to, že mám na tej strojke naozaj, že mám tam teraz pol tera alebo tera, ktoré sa potrebuje per každý podsťahovať, tak to začína byť úplne iná téma, ale je to veľmi jednoducho adaptovateľné. Miesto toho, že definujeme empty diry, začneme fungovať na nejakom storage class, ktorý to vie poskytovať a stále máme tú dynamiku toho, že vie niekto správovať to bez toho, aby potreboval nahrávať niečo napríklad na ten class priamo. Predsa len aj Kubernetes copy má svoje limity. Jo. Nejaké iné otázky? Perfektne. Tak... Áno. Ďakujem veľmi pekne. A pokiaľ by bolo niečo, tak budem sa tu ešte motať, tak sa môžeme porozprávať.
Chcem sa spýtať, že má to nejakú inú výhodu oproti GC Fuse než ten interface?
Nepoznám GC Fuse.
S3 Fuse.
S3 Fuse, dobre.
Akože GC.
Jasne, áno. Áno, není to iba na to, aby sme dostali tú S3. Aj ten Fuse, ako som sa pozeral, niekedy robí akože... Nebolo to úplne také straightforward, ako one-time vec. Že tá availability toho storage, pokiaľ sa niečo rozrasí, tak to je také, že tam stiahnem ho vám, som musel spôsob na to. To isté by som povedal, že to je ako s NFS-kou. Pokiaľ by som mal ťahať NFS-ko cez niečo väčšie ako localhost, a na tom localhostu je to také, že na táto host by som to boli asi také nejaké finálne. Keď sme to boli vlastne
teraz budeme vlastne už experimentálna verzia
Nebo na to, když byl na týmy? Tak já jsem viděl tady přes to hodinu. Tak já jsem...
Meet Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skills and maintaining versions are overwhelming tasks. John's is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production two times faster. Database admins can be 3 times more productive. Database can save up to 75% of cost of underlying cloud storage. Developers can build tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness. In what we are all against.
Or we can focus on what we're all here for.
People.
Each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging centennial giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
People with passwords like password 1, exclamation point.
For people trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves.
Security is really about.
modern IT leader, your team's role has expanded beyond supporting business operations and enabling criminal change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations. Architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation and business needs of the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in four primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the three production tiers. With the right tooling, automation, and process in place, you can boost operational performance and benefit from positive feedback with machine learning systems. Although these are conceptual tiers, they are a great way to simplify operations, consolidate services, and unify your security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments. Your security and network control and update security and network policies without slowing down production. And your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptive apps.
Meet Anna and John. They are database admins working on different teams. Anna is using an open source database system. Although databases are free to use by developers, hiring for skills and maintaining versions are overwhelming tasks. John is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With developers can push apps and features in production two times faster. Database admins can be 3 times more productive. Database can save up to 75% of cost of underlying cloud storage. Developers can build tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness. In what we are all against.
Or we can focus on what we're all here for.
People.
Each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
People with password 1, 2, 3 exclamation point.
For people trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves.
Security is really about.
modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investment to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations. Architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation that business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in four primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet isolated from the pre-production tiers. With the right tooling, automation and process in place, you can boost operational performance and benefit from positive feedback with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a secure path to speedier deployments. Your security and network control and update security and network policies without slowing down production. And your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptive apps.
Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are freely used by developers, hiring for skills and maintaining versions are overwhelming tasks. John's is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also hiring challenges. There's another standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With developers can push apps and features in production two times faster. Database admins can be 3 times more productive. Database can save up to 75% of cost of underlying cloud storage. Developers can build tolerant, secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness. In what we are all against.
Dobrý. Or we can focus on what we're all here for.
Áno, hádaj, Mičko, všetko by malo byť fajn. Môžem to skúsiť?
Each other.
Čiže zatiaľ sa to nestreamuje na
For our neighbors.
Our kids.
People with I or their job titles.
For new leaders dragging central giants into the future.
For wild thinkers.
Designated warriors.
Neviem, aké je
For the people they protect.
We're never gonna get all our čierny screen.
People with password 1, 2, 3 should play.
For people trusted strangers and lost everything.
What Titans industry.
Titans of taco trucks. Titans with toddlers.
Počkaj, to je niečo
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves.
Security is really about.
Okay. Teraz zatiaľ nič nevidím.
Skúsme to ešte odpojiť a pripojiť.
Pozriem sa, či toto náhodou. Dobre. Úplne odpojiť, pripojiť. Okay. Môžem to skúsiť spraviť softvérovo, čo to vymyslí. Odpojené. Keby niečo viem to aj niekam streamovať? Cez Google Cast alebo čo také? Cast by mohlo byť nejaké jednoduché riešenie, teoreticky, ale...
No, ale nemáme kam castiť.
OK.
Ja si to naberám, že sa viac strižne.
OK. Zoom alebo niečo podobné. Zapojím? Hádami? Zapojím. U mňa zapojené.
No, chce sa to nevyhnúť.
Je to tu? Podľa tohto žijeme. Podľa tohto nie, ale počkajte.
Ja to ešte počujem.
Naozaj to nie je iba čierna obrazovka?
Naozaj, lebo tuto by svietilo na zeleno, keby sa
OK, to neznie dobré.
Skúsme to ešte takto napriamo.
OK, tu je to fajn.
Takto sa to chytá. Prečo sa to nechytá?
Ak to má USB-C-škový vstup, môžeme skúsiť ešte USB-C-ško, ale...
To je prevodníček, ktorý tu používame na scalovanie, čo dostávame.
OK. OK.
Ja to skúsim ešte inak prerobiť.
Hej, on cez USB-C mi ide DisplayPort.
To by sme aj tak museli redukovať naspäť na HDMI.
Hej, on ide o to, že ak je pokazený HDMI konektor alebo hoci čo kvôli čomu to nejde, tak...
To si nemyslím, že tento má... Ide to v pohodičke, tú súhodičku. Takže prevodníček šajkuje. Dobre, ja mu dám ešte oddychnúť a idem zase na prvú.
Buď to, alebo môžeme ešte skúsiť dať nižšie rozlíšenie, whatever?
To pôjde.
OK. Dobre.
Jasne. Chcete ukázať nejaký čas, kedy máte skončiť nejakých 5 minút, vám ukážem pred koncom, alebo minútu pred koncom, alebo koľko chcete?
Koľko sa zvyčajne necháva na otázky?
5 minút.
5 minút pred koncom je úplne v pohode.
Dobre, takže stačí 5 minút pred koncom.
Áno, prúb, čo som si skúšal, bolo okolo 25 minút celok, takže by som mal skončiť aj skôr aj možno, ak sa to podarí.
Kľudne môžete ako tých 30 minút, máte 35 minútový blok, takže keď skončíte skôr, vieme to aj skôr zavrieť samozrejme, ale takže tak.
Jasne.
Dobre, takže stol bude v slovenčine alebo v angličtine?
V angličtine.
V angličtine, dobre, takže OK, tak aj vás v angličtine nejako predstavíme, alebo tak tieto všetky veci. Aj potom otázky asi tam v angličtine nech dávajú ľudia. Alebo ako chcú asi.
Áno, ak to budú iba Slováci, viem sa prispôsobiť aj to po slovensky. Slajdy budú anglické, s tým už nič nespravím.
Jasne, nie, to je v pohode, ale myslím, že tu máme, že tam pán je tam dole v angličtine, anglicky hovoriaci, takže asi toto bude akože v angličtine.
To je ťažká dilema lokálnych meetupov.
Áno, ako samozrejme. Dajme to v angličtine, podľa mňa, nebudem sa s tým trápiť, dobre? Nebudem sa ani pýtať, lebo pozerám, že ten sú v angličtine a ostatní, neviem teraz toto môžete povedať. Dobre.
OK, ešte sú nejaké menšie problémy s tým prevodníkom. Tak...
Ja, že ešte nefunguje niečo? Alebo...
Screen share nefunguje. Napriamo mi screen išiel na pomocnú obrazovku, ale nevie to ísť prevodníkom do štúdia.
Ja, že tento nefunguje? A tam čo sú...
Nie, tuto bol. Tento magický prevodník nefunguje.
Aha, OK.
Takže potom to nevedia streamovať.
Aha, tak uvidíme, ako to spravia.
Hej, ešte chvíľku počkám a uvidí sa.
Dobre, tak jasne.
Jasne.
Už. Dám tomu ešte jednu šancu.
Jasne. Ak je nejaký plán B, ktorý vie pomôcť, kľudne povedzte.
Je to vyloženie o vyredukovaní. Pokiaľ mi to hrá tu, no teraz sa chytil, OK, super.
Murphyho zákony?
To už budeme dobre.
A prečo tu mám iba? Počkaj, ja tu mám iba built-in display teraz, takže... OK. Vyzerá, že hej. Uvidíme, čo Murphyho zákony prinesú teraz. Ja, to ešte uvidíme, či nebudeme reštartovať uprostred prednášky.
Dobre, je to živé, áno?
Vyzerá, že je.
Vítam vás všetkých po obede. Dúfam, že budete schopní vnímať aj s plným bruchom, takže nebude to brať len tak relaxačne, ale že sa to všetko podarí. Chcel by som medzi nami privítať momentálne Milana Plžíka z Grafana Labs. Milan is a software engineer at Grafana Labs working on cloud platform team that provides international cloud platform services to the rest of the company, working mostly on low-level infrastructure, and his current focus is in automating Kubernetes cluster upgrades. And also his topic of this presentation will be upgrading Kubernetes clusters the hard way. So stage is yours.
Thanks a lot. So, hello everyone. My name is Milan, and as said before, I'm at Grafana's cloud platform team, which is basically the team that, well, platform team now, which is basically the kind of internal team that actually manages the internal infrastructure, ranging from low-level infrastructure provisioning up to the cost management, networking, or releases CI/CD, whatever. So we're the middleman between our product teams that are running their products in there, such as Memmer, Loki, hosted Grafana, and any outside cloud service providers that are providing services to us. So we're trying to basically balance between what our product teams need and what is necessary for to run correctly on the cloud service providers. Like, communication goes both sides. We basically escalate our internal issues to them. We communicate the stuff that's important that the cloud service providers are telling us to our internal customers and stuff like that. So I've been working mostly on Kubernetes upgrades for the past few quarters. And although it might seem to be quite a simple task to do, it turns out the reality might be much more complicated than that. Especially, well, ironically, in the cloud setting. So, if it's that difficult, why do the upgrades at all? So, firstly, because there's a lot of shiny new features coming up with every minor Kubernetes release, and who wouldn't want those? Well, that's true, partially. The truth is also that because the cloud service providers only support recent versions of Kubernetes, and as we all know, no support means no SLA for the clusters, meaning that we're mostly on our own. And cloud service providers often align their Kubernetes offering support with the upstream Kubernetes support, meaning that the support goes usually like few months past the upstream Kubernetes support. So it's actually, in average, like 3 upgrades a year, because that's how frequently currently their Kubernetes team does releases. And also, clusters that get too far behind with their version get auto-upgraded, meaning that, well, even if disabled, meaning that the cloud service providers are usually pretty gentle and start only upgrading the control plane of the cluster. But if the versions in the cluster starts to slip through the Kubernetes version SKU policy, they might eventually start upgrading also the node pools, which might be problematic if your workloads aren't exactly aligned with how a Kubernetes workload should work. So let's have a look at a little bit more details about the actual, what we want to achieve here. So for our purposes, the upgrade goals are to keep up with the supported Kubernetes versions, just to make sure that we're actually within the supported SLA window, minimize disruption for the cluster users, be it our product teams, which are actually running their workloads, or even the user, like the external customers of ours, which probably wouldn't want to see too much of downtime on our service. And also to provide new bug fixes, features, whatever. The bottom line there is that these are not exactly ordered priorities, and they often shuffle around. For instance, a few weeks ago, there was an issue where EKS rolled out AMI image that had a fairly nasty eBPF GIT member leak issue. And if you happen to pick that up, it was quite inconvenient and had to be upgraded pretty quickly. So at that point, the risk calculations change a little bit, and you'd rather do a little bit more disruption and risk than having a buggy image run and eventually stop being able to launch your containers. So, and speaking of disruption, so this is the important thing here as well. Disruption is a state where there are no pods available to serve user requests. Simplistic definition just for the purposes of this presentation. But the bottom line is that there are two kinds of disruption. First is a voluntary disruption. This is a disruption that's triggered using the Kubernetes API or Kubernetes internal automation, whatever. And it's the kind of disruption that we're actually pretty much in control in. So we can affect this disruption multiple ways by doing kubectl delete if we want to enforce something, or actually configuring our workloads to not do any kind of disruption if there's a risk of problems. Then there's also involuntary disruption. That's usually the disruption caused by external forces such as machine failure, so on and so forth. So this presentation will focus mostly on the voluntary disruption, but as for the involuntary one, that's a topic on its own, because although it might not seem like that, this is happening all the time. So even if we not see that, at the scale of cloud service providers, there's a lot of stuff happening on the VMs. Like there's always some kind of memory issues, hardware failure, upgrades, or the servers get hit by neutrinos, you name it. And some of these issues can be quite successfully masked by, for instance, live VM migration, whereas some others, such as memory corruption or anything like that, can't be masked at all, and they just result in the VM going down, whether we like it or not. And this is basically an end scenario for us, because at this point, we can't predict whether a neutrino hits a particular bit in memory. And the only thing we can do to avoid external facing issues to be really prepared for the worst and hope it won't happen. So this presentation will focus on the voluntary disruption mostly. So the way of Kubernetes operates. Kubernetes works best with the workloads that can handle involuntary disruption of a pod or two in a workload. That makes complete sense. Like ideally stateless microservices, if you just shovel one away, the others can step in and replace it with no issues. Note that any single pod, if deleted, if removed, causes an outage. There's no easy way to work around that. And at that point, we're basically just calculating the risks and trying to see how much of downtime we can afford. The automation for the Kubernetes upgrades, the automation usually drains each node and replaces it with an upgraded one. And along the process, it drains all the pods that are running on that node and hopes that they will schedule successfully on the new node. There are several mechanisms built into Kubernetes to make this as seamless as possible. Well, and then there's the reality of Kubernetes upgrades. Not all software is made equal, and that's especially valid for stuff that was designed before we were actually running stuff mostly in the Kubernetes clusters. So pre-Kubernetes software uses its own means of handling multi-node deployments. So there's a lot of software stacks that has its own draining and multi-replica master election algorithms implemented. And these are sometimes not exactly easily mappable into Kubernetes. For instance, we have a lot of SQL servers that do have some master-slave replication. Well, master-replica replication, sorry. The problem there is that this doesn't map correctly into what Kubernetes expects. Kubernetes is quite egalitarian. So take any single pod, shoot it down, and the other pods should step in. This doesn't hold for the traditional SQL Server layout, where if you kill off the master, the cluster of the SQL servers is for a moment unable to do writes because you only have the replicas that might be serving your database. So there's a new round of master election reconciliation needs to be done in order to make stuff running up again. So it's not as easy. For a SQL replica, that would be much, much easier because you usually only have to spin up new pod and either replicate the state, and while you're replicating, the other replicas can easily step in and serve the content. Some software supports running only as a single replica. So some software was written without any kind of multi-tenancy, well, multi-replica running setting in mind. So that's running that in multiple replicas in parallel can easily result in having lots of race conditions, stuff like that. And usually we don't want to happen. And also, even for stuff that's fairly okay-ish running in a cluster, there are a lot of edge cases that we can inadvertently trigger, such as having one big Kafka cluster that's serving a lot of small product clusters. And if we do too much or too quick rolling restarts in those product clusters, suddenly the Kafka gets overwhelmed just by pulling all the data in because a lot of paths has restarted almost simultaneously. And well, triggers cascading failure, which is not something we would like to do. So TLDR, there is some software is fairly sensitive to disruption and needs special handling, whether we like it or not. So with that in mind, how to minimize disruption for sensitive workloads, as we talked before in the previous slide. So firstly, and maybe a little bit, well, ironically, don't run it at Kubernetes. There's some software that doesn't fit the Kubernetes concept that well. And consider either using the CSP's offerings. We're upgrading cloud Kubernetes, so chances are you do have some offerings that you can use in place of like on-prem SQL servers or object storage or whatever. And the CSPs have actually invested quite a lot in developing the automation for this and trying to make it as seamless as possible to use. Like it might not be, it's not a one-size-fits-all solution, but it might be good enough for you. At least it might be able to prevent you from hiring a separate databases and storage team just to get your SQL server, well, MySQL clusters handled correctly. So this is something that should be definitely considered. The other thing is running the workloads on VMs instead. So if Kubernetes is too disruptive, VMs are much more stable and they can still go down, but there's an SLA provided by the cloud service providers, and they go only down if there's something really bad happening. So not from the reasons that the control plane decided that we're spending too much because these VMs are underutilized, let's just shoot up this VM. So the other thing is run it on Kubernetes, but carefully. So there's always a way to be a little bit more gentle to workloads, meaning we can use a dedicated node pool or node group to run the workloads and retain some lifecycle control, meaning we won't be that much susceptible to disruption that's caused by like a generic full-packed Kubernetes node. And also we can trigger the node pool upgrades for separate node pools. So there's at least this knob for fine-grained control. And we can, like, for instance, create separate node pools for each database we use, or alternatively for each workload that we use that we know that uses the common database backend, and slightly throttle any kind of rollout restarts that might happen over the course. And the other thing is we can use existing Kubernetes operators. So the operators are basically software that tries to break the Kubernetes API and whatever is happening inside the distributed software that might not be fully Kubernetes native, meaning translating all the magic state, like what's the current state of replication for this node? Is this node fully populated or not yet whatsoever? And once Kubernetes knows about these details, where in Kubernetes terms, it might be a little bit easier for it to handle some disruption. And it also helps with recovery. So if Elasticsearch node goes down, the operator can easily notify the Kubernetes cluster that maybe there's a new node spinning up, there's a replication happening, please don't do any kind of disruption right now, and similar things. So it might be able to do some things. It's not like a silver bullet, but it definitely helps when running some software that's not designed to be totally Kubernetes native. And the last thing is embrace Kubernetes. Well, that's probably easier said than done, because like it's fix the code to be Kubernetes native or implement it in operator yourself, like single sentence, even with exclamation mark at the end. The truth is that if there's no existing operator and the built-in Kubernetes controllers such as deployment or stateful set or daemon set don't fit the bill, well, it's probably the way to go, but involves a lot of coding and debugging, which usually needs to have its price justified because it's a software development issue. It's not a DevOps issue anymore. And with that, now we have our Kubernetes cluster with a lot of workloads in there running. Let's have a look at how to manage the upgrade. So firstly, there's the CSP way. That's probably the most easy in the terms of maintenance or whatsoever. It works as simple as it sounds. So it deletes the old nodes and the pods on it, spins up new nodes, running new version of Kubernetes, and respins the new pods there. The deleted pods there. And the trouble, as usual, is that deleting a single replica workload pod causes an outage. Well, obvious one. The bigger workloads still need to correctly communicate their health to avoid outages. Usually, this should be okay. Sometimes there might be corner cases. And the problem is that there's little control over the process, meaning that once we start the upgrade, the CSPs usually either run the process until it fails, or like there might be a knob that actually allows to stop or cancel a node pool upgrade, but it ends up in an intermediary state where you actually have half of the nodes upgraded to one version, the other half to the other version, and it's not a totally good idea. So the meta algorithm is basically upgrade control plane for each node pool and each old node in the node pool, pre-spin up a new node that's already running in the new Kubernetes version, and for all the pods on that node, delete the pod and hope for the best. Well, delete the pod is a little bit more intricate than that, because there are Kubernetes native control mechanisms for this. So there's the pod readiness health probes that actually allow Kubernetes to see whether the pod feels healthy, as in the pod is okay-ish and doesn't need to be killed. If a pod gets unhealthy for a too long period, Kubernetes just kills it off. Or ready, unready, which might be as well used for indicating where there is the pod has pulled all in the data that it needs and can be included in load balancing or not. So then there's controller rollout strategy. So actually, Kubernetes controllers are able to provide you with, for instance, extra pod if you're doing Kubernetes rolling restart. So the magic there is that this is not a regular disruption, as in deleting pod, but instead there's a mechanism to do kubectl rollout restart. Tells the controller that it might tell the controller that there's also a need to spin up new search pod. Then we have pod disruption budgets, which attempt to control how many of the pods can go down. And if there's a request to delete more pods, it will get blocked. This is an important bit because it also, so there's a difference between pod deletion and pod eviction. We'll come to that a little bit later. We have priest-up hook that basically tries to execute some code before the actual pod gets deleted, and then we have Kubernetes object finalizers, which is a sort of magic metadata for Kubernetes objects that gets added by finalizers. And if a Kubernetes object ever gets deleted, it doesn't get deleted instantly, but instead its deletion time is configured to be some current timestamp. And then the Kubernetes waits until the finalizers all go through the object, which they should. They should watch all the objects for which they do have the finalizer metadata configured. And once they remove all the finalizers from the Kubernetes object's description, it gets deleted. So it's basically a helper to make sure that some actions are run before the object gets totally deleted and forgotten from Kubernetes. So then there's the manual way of upgrading, which is much, much more tedious, but also much more safe. So this means basically a node pool migration. So instead of using CSP's button to just do the node pool upgrade, we can upgrade the control plane of the Kubernetes cluster and then start spinning up new node pools. Those new node pools will be running new Kubernetes version, which is totally fine for us. And then comes the hard part, which is migrating the content of the old node pool to the new node pool, and also ensuring that stuff really works out correctly. This usually means that we need to taint the old node pool with some taint that prevents any new workload spinning there. That usually means the no-schedule taint. And then proceed with careful pod deletion. The important bit is that now we're in the control of deleting the pods, and we can implement a lot of our own safety checks and any kind of magic that we need to ensure that we don't break our production totally. The drawback there is that this gives a lot of fine-grained control to the human operator, and thus is also quite tedious. Like, this works for a few tens of pods, but if you have like hundreds or thousands of pods running in your cluster, you probably don't want to drain all the pods with a single command, because you, for one, risk that you usually forget that sleep 30 in your for loop that's supposed to throttle the pod deletions. And the other thing is that one is easily able to miss out something, like there's plenty of space for human error, which we should probably avoid. So then there's this approach of controlling the upgrade using the code, meaning that instead of writing a normal operator, we would be writing a sort of kind of upgrade operator that carefully tries to do the manual thing. For each node in the old cluster, it basically tries to use eviction API to mark a pod for deletion. The difference between deletion and eviction is that the eviction API tells Kubernetes API that this pod should get deleted. We'd like to have it deleted, but let's respect all the rules that are set in the cluster. So PDB gets respected. Any other things are totally getting respected. If there are conditions that would be broken, like PDB, the pod's deletion would just stall and not get deleted until the conditions are met again. So this is a fairly safe thing. And also a few hundreds of lines of code from our operatorless, because we don't need to care about PDBs explicitly. In this code, we can easily special case our own workloads that are problematic and implement any kind of waits of timeouts necessary. So this is a operator, but it only works for upgrades. That's the important thing, and it still doesn't prevent any disruption that's not related to upgrades. But for purposes of this presentation, well, it fits the bill. For any kind of more intricate things, you probably still want to use a normal operator. Oh, and the bonus: avoiding single pod outages. So what I repeat a few times across the presentation is that single pod outages are problematic because, like, if you have single replica workload, like killing the pod, well, it kills the pod and the whole service with it. So the bottom line is that there's really no way to really avoid that, but there might be some compromises if you are able to run the two pods of the replica of the workload for at least short period of time. In that case, you can use that property of deployment deployment manifest that actually allows you to configure a surge pod. So with that manual process for upgrading, instead of doing a kubectl delete pod or evict or whatever, there's a way to trigger kubectl rollout restart, which is able to spin up a surge pod before the old pod actually gets deleted, and this does precisely the thing we want. It spins up a new pod, waits until it's healthy, and then tries to spin down the old pod. So ideally, this shouldn't be too problematic and should work. The only problem is that it only works with that special kubectl rolled restart command. If you do any kind of kubectl pod delete pod, the stuff goes directly to the pod, and the pod gets terminated before the controller actually realizes that it should start spinning up new pod. So there is this gap where you don't have anything serving. So, and the experience at Grafana Labs. So how do we run our infra is that we have a lot of services that are already Kubernetes native, meaning that we don't need to care too much about actually running the about how to drain them properly. It mostly works, and it works correctly. There are some special cases, though, special snowflakes even. So hosted Grafana. So if you try to run Grafana in a multi-tenant setting, it's not that easy. There are some bits that are not designed to be ran in a multi-tenant setting. Well, sorry, multi-replica setting. And if ran for a long time, for instance, there would be extra alerting rule evaluations, all stuff like that, which is not something that we want. But this is exactly the setting I talked about previously. So for a short period of time, it's actually okay to run two Grafana pods at once. So when we are doing Kubernetes upgrades, except for running upgrading the other things, for hosted Grafana, we do the special node pool migration when we spin up a new node pool, which is a separate node pool just for hosted Grafana, and then carefully do kubectl rollout restart on the service so that it actually spins up the search pods and the search pods land on the new node pool, which is careful and mostly okay-ish. It doesn't break too much. And also, for more sensitive services, we throttle their upgrades. So we do have a manual sort of upgrader that goes through our sensitive workloads and tries to carefully restart them and wait until they become fully healthy. It does even a single node throttling, meaning that it doesn't try to drain the whole node at once. Instead, it really takes care to only drain few pods at the node at the same time, wait until the controllers indicate that everything is healthy again, then proceed further. And with that, we're able to do stuff fairly okay-ish. Meaning there's always some fun associated with upgrades, because it's still mass restart, but it's fairly under control, and we're quite careful and adjusting the process as it goes. So, and what about the future? So, our heading right now is to converge on the CSP upgrade process, which is probably the cheapest way and also the way that it probably should work. But chances are that this won't ever happen. Like, the world isn't ideal. We have some ideal things in physics and stuff like that, ideal gas, mass point, and so on and so forth, but this is not the case. We're in the real world, and there's always going to be workloads that might need special casing. So for hosted Grafana, there are some efforts to make that a little bit more streamlined. But as we are trying to do that, there are some new workloads popping up that might need special casing as well. And we're looking into Carpenter, which is a different take on node group scaling, so for now on EKS. And that's actually a little bit of opposite to what we're doing, because upgraders in the sense of Carpenter are not something that we would need to just start device a week or two for and then finish. But instead, Carpenter allows to configure a TTL for each node in the node group that it manages. So instead of like really start-stop kind of upgrades, we would have continuous upgrades. Carpenter would just pick the most recent version that's running on the Kubernetes master nodes, and once a node's TTL gets reached, the node will get deleted, and instead of it, a new node with the current version would be spun up. So we'll see how stuff goes from there. But it's really fun to upgrade Kubernetes clusters that are running a lot of production workloads and see the differences between what's Kubernetes native and what is not exactly. So with that, this is my last slide. So I'm open to any questions you might have. On Slido or in person? Oh, yep. I think I'll do my best. Okay, so what was your worst experience with an upgrade? the worst issue? What was your best experience with an upgrade? Everything was working well. Okay, the worst experience actually happens quite often before the actual upgrade. Okay, the worst experience ever, but that's not going to happen anymore, is I think 1.19 to 1.20 or something like that. Back in times when Grafana clusters had a little bit of more like custom tweaking to it. So we were running on GKE, but we're using the GCLB directly to address. Basically, we were using GCLB pointed to a instance group that was created by Kubernetes clusters, meaning that so our upgrade process inadvertently changes instance groups that are backing any kind of node pools that we have. And if we were really pointing manually a GC load balancer to a specific instance group, chances are that you at some point forget to add the new instance group to the actual backend. And, well, stuff can get really broken in funny ways then. You basically, everything works until you have at least one. So our system was designed that if there was at least one node in the old node group that was supposed to be deleted, everything was just working fine and routed correctly. Once the last node from the old node group got deleted, everything just went blank. And I think there was an outage about this as well, but I don't remember exactly. Right now, we moved to a more streamlined solution that actually is in line with what the GKE is trying to design. So that works much well. And, well, other than that, just TLDR, any kind of breaking API changes are always a challenge, and trying to be sure that all the Kubernetes objects you are using the correct API version and that nothing breaks. That's the usual chore we need to do before each upgrade if there's any breaking change. And it's a lot of fun. The best experience usually, so that's actually a continuous process. We started to automate our upgrades quite a lot because we're running now a fair amount of clusters which are fairly big. So we wrote a tool that basically worked with our internal GitOps repo and tries to submit PRs for each change. So we actually started doing a little bit no-ops automation, if you know the term. It's basically writing a code that only tells you what to do. So you'll write a program that basically shows you the steps that you need to do and maybe checks whether the steps were actually done. And then you can slowly automate the steps and try and make it more and more hands-off. So we did that, and that slowly allowed us to basically automate ourselves out of the low-level per node pool upgrades. So right now we have per cluster upgrades with us only approving the PRs that the tool generates, and it's much less brittle than it was before. And we're still moving toward eventually having maybe at some point single-click cluster fleet upgrade, if such a thing ever exists. But we'll see. So how do you perform controlled node drain? Great question. So firstly, I'm not sure if that question was in a setting of automated or manual node upgrades, because for manual node upgrades, it's quite easy. So tainting the node so that it actually so that the Kubernetes scheduler will avoid that node ever, and not schedule anything there. And then basically our tooling just fetches the list of the pods that are running there, which is fairly easy using Kubernetes API, and tries to figure out firstly, for the sensitive workloads, the owner of each pod and generate kubectl rollout restart on those controllers so that those pods get moved to other nodes. Well, and for the remaining pods, it just uses the eviction API. And the last question, what is your time estimation upgrading Kubernetes from 1.20 to 1.25? Oh, that's like 5 versions. To be honest, I'm not totally sure. Currently, a upgrade between minor versions takes us around week, more like week or two of time. So multiply that by 5 and you'll end up with a quarter or so if we went from really 0.20 to 0.25. We could probably take some shortcuts there, and stuff would go easier, but still the manual process, like we have big clusters that take days to completely upgrade. So I wouldn't probably go lower than a week per total upgrade. If we are completely sure we would be re-rolling all clusters at once without any canarying and stuff like that. But we are not in a race to upgrade the fleet in the shortest time, but to upgrade it the safest way we can. Okay. Oh, last question. Do we still have a few seconds of time? Okay. It's not a matter of time upgrading from 1.25 to 20 to 25, rather the amount of pain to manage. So from that point of view, it really depends on the tooling at hand. If we had to do that in the way that you are doing 1.17 or 1.18 upgrades, that would be really painful because that actually involved manually doing a lot of stuff on per node pool basis and then running our tooling to drain the node pools, stuff like that, even manually adjusting the instance groups. That was really painful, and I wouldn't want to do that anymore because it's a recipe for disaster. With our current tooling, it's much easier. It's more about tracking which clusters did get upgraded, which not, where something did break, because some things do break, especially on dev clusters where people are not as diligent with keeping up with not crash looping stuff. But depends. That's it.
Thank you very much.
Okay.
Okay, sure, we can start.
Let me, please, just for a second. The microphone.
Oh, sure.
Takže teraz bude nasledovať prednáška s názvom Fast, Faster, Fastest, Object Storage, Cloudbox Storage and SSD, ktorého speakerom teda bude Laszlo Madáros, ktorý je špecialistom v UI engineering odbore a zastupuje tú firmu Altinities. So stage is yours.
Okay, thank you for the introduction and welcome everyone. I'm very excited to be here. My name is Laszlo Madáros and today's topic is going to be about cloud storage performance. And before we get into that, I would like to ask to raise your hand if you work with any form of cloud storage. Okay, that's quite a lot. Then this is probably going to be interesting for you. And I think it's also in the title that we're going to look at analytic databases, which is a pretty specific topic, but I think what we found can be interesting for everyone here. So first, let me introduce myself quickly. I am a UI engineer at Altinity, and this presentation was put together with the original mastermind, Robert Hodges, who is the CEO of Altinity. And Altinity provides enterprise services for companies who use ClickHouse. And ClickHouse is a magnificent analytic database. I will tell you a few words about that a bit later. Sorry, just a moment. I just want to make this a bit larger. Yes, thank you. So you can see a few of the main questions that we are going to have today. First, I'm going to introduce three main forms of storage that we can encounter in the cloud. And I want to say that I'm going to bring examples from Amazon. So the product names that I'm going to use are going to be from Amazon. But if you use any other major storage provider, you probably encounter the same kind of storage system, just under different names. And I'm also going to talk a bit about how we can measure performance, because it's really tricky, especially with databases. It has a lot of factors. I'm going to say a few words about what an analytic database is, and then we go into the main topic, which is how storage affects analytic database performance. So first, let's go into how these storage types work. So first, what we're going to look at is the NVMe SSD. How many of you have heard about this, just so I know who I'm talking to? Okay. So basically how an NVMe SSD works is that it is physically connected to the host machine. And whenever you rent like a host, you usually don't rent the whole physical machine, but you only rent the virtual machine. And the trick here is that although it seems logical that you can only use part of the SSD when you rent a part of a machine, which can be surprising is that whenever you have a throughput, like whenever you have a bandwidth there, you can also get part of that bandwidth because it is related to the virtual CPUs that you use. And the reason is that NVMe is a technology where, like compared to the older standard like SATA, SSD is directly connected to the CPU, and this allows for great bandwidth, but also directly correlates with CPU performance. So here you can see a few tests that we have done. The way we did this test is that we wrote a small program, and we just told it that it should write the same file 50 times, and we just looked at the results. And this file was about half a gigabyte. So if you look at the left, those are the write performance data. And what is interesting about is that the times that it took to write these files are scattered around, and then everything just gets into line, and also it gets lower, like this, the speed seems to increase. So the first question is, what causes this like instability in the beginning? And the answer is that we couldn't figure out. Our guess is that it's probably because it's in the cloud. There could be a lot of factors, for example, network problems or any problems that the provider currently had. Yes, the interesting thing is that it only happens with NVMe SSD, so none of the other storage methods will produce this. But after that, for about the last third, we can see that the write performance just goes up, like it takes very little time to write a file. And our idea here is that probably a write cache starts to work here. Because one important thing that I didn't mention here, that whenever we use an NVMe, we can also use the operating system's cache, which helps us both with writing and reading data. And we will see later that this is not true for all of the storage methods. So when we look at reading, we can also see this caching effect. Like when we read the files for the first time, it takes more than 1 second for each file, and then it gets to about the half of this time when we only read from the cache. And as I mentioned, the performance or the bandwidth correlates with the CPU size. So on this graph here, this might be a bit difficult to interpret at first, because here we measure the write duration, and also we order them by the amount. So what you can see here is the around 0 we see the fastest write speeds, and around 100 the slowest write speeds for both virtual machines. And the one in the blue, as you can see, is 4 times like a 4 times stronger machine than the one marked with red. And what you can see is that like around the edges they have similar performance, but when we go to the main part, the most usual result, the one with the larger performance, basically it performs almost exactly 4 times faster. So this is what we would expect, because we have a 4 times faster CPU here. Okay, so let's move on to the next form of storage, which is the block storage. So the difference here is that the block storage is connected over a network, and the machine doesn't really know about this network, doesn't know how it works. It just sees the whole network as hard disk, basically. And what is similar to the NVMe, that we can also use the operating system cache here, so we also have this advantage here. When we look at the performance, what we can see is that it is mostly slightly slower than an NVMe. It has some differences. As I said, we don't see this kind of instability that we had before, but we see the same buffer or cache effect. Like when writing, we can see that this buffer gets saturated, and then we get slower writing times. And when reading, we see the exact opposite. Like first it reads, like every read takes almost 4 seconds, and then it actually performs better than the NVMe when it reads from the cache. Again, like these are measurements that we took for ourselves, so we cannot explain everything exactly. Like maybe Amazon knows the reason why these work like this. We just wanted to see if we put them among certain circumstances, how they will perform. Okay, so our last type of storage is S3 object storage, which is a completely different story, like a completely different way of working with storage. It works a lot like an API, like you can just like basically put requests to create or get files, but you cannot modify them when they are already created. You cannot just modify a part of a file. And also what you cannot do is you cannot use the operating system cache. And as you can see here, all of these graphs are linear, like there is no sudden change in the performance. But still, when writing, it performs similar to the block storage. And when reading, it actually gives a pretty good performance when we don't consider the cache. So if we would test all storage types without a cache, this would be a pretty good result. But if you compare it to the cache result, it's inferior to the other storage methods. So here's a comparison of all three methods. And this only takes reading times for consideration. And what you can see here is that like S3 is the slowest of them all. Like it takes it the most time to read. But also for, like, this is again a percentage, so we can take a look at like the fastest and the slowest like read commands or like read executions. And you can also see that if you talk about block storage, we also get some pretty slow results. That's probably when the cache like couldn't fire up yet. And the NVMe is like constantly performing at a good rate. Okay, so what now we are going to do is we take a real use case, like we try to run a database on all of these storage types and see how it performs. Because what is going to be interesting is that even if you have these storage types and these storage type results, running a database is a completely different thing. So I would like to introduce ClickHouse. As I said, we at Altinity provide support for ClickHouse, which is an analytic database that runs like any other SQL database. It can run on any environment. It runs on my laptop. It can run on the cloud. And what it excels at is dealing with like huge amounts of data. And when I say huge, I mean like hundreds of billions or even trillions of rows, which is, if you take a MySQL database, it would probably collapse, or like it would take a lot of time to fetch data from a database of this size. And the way it can work is that it stores data in columns. So whenever we make a query, we don't have to read all of the columns. It only reads the columns that we actually need. It also has very good compression. It utilizes something that's called the shared nothing architecture, which means that every node, like it can be distributed to different nodes, and every node has its own computing function and storage function, and there is no overlap. So this enables us to run queries in parallel. So we just run one query, and all of the nodes can do this simultaneously on multiple threads, which gives a huge advantage in processing all of this data. And also, it is open source. So, as we are on a Kubernetes conference, one of the reasons that we brought this topic is because we run this whole thing on Kubernetes. Like Robert, who actually created this presentation, he has been working with databases for over 30 years, and he told me that when he first encountered ClickHouse, it was actually a real challenge to set it up. Like it requires a very complicated infrastructure, like multiple nodes connected, and Kubernetes makes it really simple for us to, it actually takes about a minute to bring up a whole ClickHouse cluster using Kubernetes. And as you can see, there is like a rough outline how it looks in Kubernetes. Like we have a stateful set, which contains all of the pods, which represent processes running on the hosts. And the other important part is like, the first important part is the processes. The other important part is the storage that we use. And for this, we use persistent volume clays, which will turn into persistent volumes. And in this example, we put AWS EBS storage here, but it can be any storage that we'd like to use for that database. And Altinity developed an operator called Altinity ClickHouse operator, which is responsible for setting up ClickHouse on Kubernetes. I think everyone here is probably familiar with how operators work because I've also heard it's in the previous presentation. Yeah, basically our operator makes sure that the correct resources are created and maintaining them so that there will be no unexpected errors. If one of them goes down, we can start a new one, etc. And what I would like to show you is that, and this is going to be a bit tricky because I have this tiny screen here, how easy it is to set up a whole ClickHouse cluster. So this is about all of the code that we need to start a ClickHouse cluster in Kubernetes. And actually, this is more than that. Like we don't even need this part with the users. And if I'm correct, this one is for NVMe. Or no, sorry, this one is for EBS, and this one is for NVMe. And you probably see how little change there happened. And we could just simply switch to a completely different storage. And as I said, this is a really complex database system. Like enterprises use this to store like trillions of rows of data. And still, this is the only code that we need to run this in Kubernetes. So I think this is really, really amazing. And this is about what we described in this file. Like this is what it translates to. Like this, like on the left, you can see an instance with an NVMe SSD, and on the other side with block storage. So the way we tested is that there is a benchmark tool called ClickBench, which is specifically for analytic databases. Like it basically runs queries which are realistic queries, like ones that we would run in e-commerce. And it runs a bunch of them, about 40 something, and it runs them multiple times. So we can also see like the effect of like starting up, because of course when we start up the database, it's going to be a bit slower probably. It also checks caching. So the first test that we did here, and before I get into this, I need to say that we didn't even test S3 with these results, because from the previous test result, it was clear that it's not going to be the fastest, because it simply takes a lot of time to read from it. So the first test that we took were on NVMe. And the interesting thing here is that, like, you can see with blue the results that we did when caching was enabled. And the red one means that we disabled the operating system cache. And there is almost no difference between the two. So how can this happen? Like, as you could see in the previous examples, cache improved performance a lot. So why doesn't it work like this here? The thing is that, and this is why it's really like it really makes a huge difference what kind of database and how you use it, that ClickHouse already minimizes input and output operations, and provides us with a lot of small tools that will speed up the whole process. So basically, it's a substitute for operating system cache. Also, you can, as I said earlier, you can read in parallel, which again speeds up the whole process and maybe even makes the operating system cache obsolete in this case. Also, one more thing that I didn't say here is that the queries provided by ClickBench are dominated by compute. So we probably do more computation here than I/O operations. That also makes a difference in this case. But as you will see in the next example, it's not only about that. So for the next case, we did a test on the block storage, EBS. And what you can see here is that it's also pretty quick. Like it's not left behind compared to NVMe, although it should fall behind at least like more significantly than this. There is an interesting spike there. I won't go into that now, but if someone doesn't know what to ask at the end, then I suggest this because I think this is really interesting. So what you could see here is that there is not a lot of difference, even though the storage types themselves provide different bandwidths. And this is what I just explained earlier, that ClickHouse provides all of these tools for caching and basically speeds up the whole process a lot. So this is the two results that we have seen, like the last two results, and put next to each other. Both of them are cached. So the blue one is NVMe, the red one is the block storage. And the surprise here is that the block storage is actually not slower, but faster in all of those queries, which is the exact opposite of what we expected. So why is this? There's actually a little trick here. When we used the block storage, we used a different type of VM. And I think there are, like most people will point out quickly what the difference is. We used a larger VM for the block storage. And even though the storage itself is supposed to have less bandwidth, still the CPU drowns this effect, and we will still get better performance with a larger CPU. So what is the conclusion here? It's actually just a few simple points that might be interesting for you if you think about what kind of virtual machine or other cloud service to order from Amazon or any other cloud provider. The first thing is that VM size affects not only computation but also I/O bandwidth. So if you use a larger VM, you will get more throughput. The other thing is that object storage doesn't use a cache. If you want to make it faster, you need to develop a cache yourself. Also, ClickHouse, and this is interesting for those of you who want to work with a huge amount of data and analyze it quickly, that ClickHouse tries to make all of these I/O operations small and like small in number and small in size. Also, what I have already mentioned is that computation-intensive queries will drown the I/O effect. So again, you can have a lot of bandwidth, but still CPU can win this race. And the opposite of this, that if you use an i3 or any kind of small VM on Amazon, this might be the bottleneck on your storage access. And the final and probably most important thing is that databases are complicated, and not only databases, but all kinds of applications. So what we recommend is that each time you plan to plan an infrastructure, you should do your own tests that are specific to the use cases that you have. Because as you could see, whenever we switched the use case, we got completely different results with completely different winners. So that was it. If you have any questions, I think we still have plenty of time. You can also visit alternity.com or find me on LinkedIn if you have any more questions, or find me outside here. But yeah, first, I think we can get into the questions part. Oh, what do you prefer, local storage or network storage? Oh yes, that's a great question, because I personally, I don't run anything that needs this volume of storage. So whenever I need to, whenever I need to run something for myself, it's not of this scale. What I can say is that our customers usually decide based on their needs, which are many times actually security needs. So many times they choose to run their ClickHouse on their local servers, because this way they can get certified for different security certificates. So usually I see that this is the main reason of the choice. But also probably, I don't work closely with these people. As I said in the beginning, I work mostly on the UI. So there are probably people who could tell better in the company. And yes, if you want to get into it more deeply, we are happy to answer, our support team is happy to answer your question. Okay. And it seems like that's it. So thank you a lot for your attention. And oh, sorry. Oh, yeah. Thank you for the question. Yeah, that was really interesting to me when I first saw that. So we looked into that query, and the interesting thing there was that it included both a lot of computations and a lot of I/O. So what happened there is that, sorry? So what happened there is basically just, that was already outside of the range that ClickHouse could optimize. There we needed the operating system to step in and do its own cache. So even you could see that for most of this graph, we had pretty uniform results. But even this difference of the use case, even the query that we are going to use is going to change what hardware we should possibly use. Okay. Was that clear? Yes. Okay. Okay, so thank you a lot for your attention, and enjoy your time here.
Thank you for your presentation.
Oh, I thank you for the...
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People. Congratulations.
Oh my God.
Each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
Oh my God! Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, Appleware, and container granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves.
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
OK, tak ďalším prezentujúcim bude Milan Skuhra zo Solargisu a porozpráva nám o Argo CD niečo. Tak, nech sa páči.
Ďakujem. Tak hneď na začiatku tu je QR kód, kde sú slajdy k dispozícii, tak ak chcete si to uchovať, tak si to môžete naskenovať a pozerať od seba. A ja by som teda začal. Ako viete, včera som mal aj workshop o Argo CD. Ak ste sa neho nemohli účastniť, lebo ste chceli byť na iných prezentáciách, tak tu je linka na ten workshop. Je koncipovaný tým spôsobom, že každý si to môže vlastne prejsť sám. Klaster je vytvorený pomocou K3D v Dockeri, takže je to veľmi ľahké nasetapovať a vyskúšať si ho samostatne. Včera sme vlastne prešli prvé časti až po, keď si to otvoríme, tak je to vlastne Wikipage na GitLabe, takže sme prešli po Secret Management a ešte som tam pridal web-based terminál, pokiaľ by to niekoho zaujímalo, tak si to vlastne môže nasetapovať, potom môže vlastne pristupovať k potom takto. To je len taká odbočka. Dobre, čo to je Argo CD? Vygooglil som si takúto peknú poučku. Definíciu open source GitHub's Continuous Delivery Tool. Je to vlastne tool, ktorý pozerá do Git repository a do klastra. A porovnáva resursy, ktoré sú definované na obidvoch miestach. Ak tam zistí nejaký rozdiel, tak buď nás o tom notifikuje, alebo ho rovno vyrieši. A to, ako ho rieši, vlastne o tom je celé Argo. Ešte sa mi páčila taká vec, že premenia ClickOps na GitOps. Čiže je to veľmi efektívny nástroj na implementáciu GitOps vo firme. Argo CD vlastne tie resursy, ktoré porovnáva v Gite a v klastri, uzatvára alebo zgrupuje do aplikácií. A aplikácia je vlastne tiež resource, takže dá sa na to pozerať ako aj na resource, ale je to vlastne niečo, čo zgrupuje iné resursy. A má vlastne dve funkcie. Ukazuje, že do ktorého repozitóry sa má Argo pozerať a do ktorého klastra sa má pozerať, respektíve namespaceu a páthy týchto dvoch resursov. To je asi zjednodušená aplikácia. Ďalej, Argo má pojem ako projekt. Projekt je vlastne niečo, čo zgrupuje aplikácie dokopy a projekt umožňuje ako keby fine-tunovať prístupy pre určité týmy. Čiže to je taká ukážka, ako vlastne fungujú projekty, že máme projekt 1, kde sú vlastne týmy, kde jeden tím deployuje svoje aplikácie zo svojich Git repozitorov do konkrétnych namespaceov a máme projekt 2, kde je druhý tím, ktorý implementuje do iných resursov. A my môžeme vlastne takto striktne oddeliť práva, prístupy a je to veľmi efektívny nástroj, ako s týmto narábať. Toto sú dve základné koncepty. Možno projekt hneď na začiatku, keď si inštalujete Argo, ani nevyskočí ako koncept lebo je tam defaultný, ale neskôr, keď chcete robiť pre viacero tímov, určite sa s tým stretnete. Tunak je ukážka, ako vlastne funguje GitOps pipeline spolu s Argom. Že vlastne ten prvý riadok, build, test a docker push, je základné vybuildovanie, otestovanie a šerovanie Docker imageov. Môžeme to vlastne pripojiť ako keby ďalšiu trojicu, kde vlastne pracujeme s Git repozitorom, teda config repository. Config repository môže byť ten istý repozitár, ktorý je vlastne pre developovanie aplikácie, ale môže to byť aj rozdielný. Ak je to teda rozdielný repozitár, tak táto šipka sa väčšinou rieši teda nejakým triggerom z jedného projektu do druhého a potom sa updateujú manifesty a commitne sa. Aby som o tom nehovoril len tak teoreticky, tak ukážem, ako to máme riešené u nás. Tu máme jeden projekt, kde sa vlastne vybuduje image a potom potrebujeme deployovať. Čiže build je klasický, je Docker build image a potom chceme deployovať buď do test prostredia alebo produkčného prostredia podľa nejakých podmienok. A jedine, čo potrebujeme, je zavolať URL-ku s nejakými parametrami. To znamená, aký je aktuálny image, aký tam bol, povedzme, posledný commit. To je užitočné hodiť do labelov, lebo keď je v label ten commit, tak vieme presne identifikovať, o ktorú verziu sa jednalo a jednak nám to zabezpečuje automatický reload deploymentu pri nasadení. Táto URL-ka vlastne volá druhý projekt, kde je vlastne konfigurácia toho, čo má byť nasadené. A tu je taká ukážka, že ako to vlastne funguje. Ja si v tom druhom projekte vytvorím teda token, ktorý je volaný. Takže nám mi tu rovno ukáže example, ako sa to môže zavolať. Dá sa to dokonca zavolať aj cez webhook, čo je možno ešte jednoduchší spôsob, ale ťažšie sa tam odozdávajú parametre. Dobre. Potom v tomto projekte, ktorý je vlastne triggerovaný cez takýto triggering, teda, tak tento robí to, že spracuje teda ten event, preberie všetky tie parametre a updateuje nejaký súbor. To je vlastne niečo, čo zabezpečuje vybuildovanie korektných resursov. A ak tam nastala teda nejaká zmena, lebo nie každý trigger môže byť taký, že spôsobí nejakú zmenu, tak nakonfigurujem tu vlastne to, že ja si tie zmeny môžem pušnúť naspäť do svojho repozitára. A potom tá pipeline vyzerá tak, že niekto ma zavolal, tento trigger, to beží podo mňou, lebo ja som ho vytvoril. Tunak beží vlastne build, ktorý commitne sám seba a commitne ho s prepínačom skipped, to znamená, že ďalší job nespúšťa, aby to nezostalo zacyklené. A takto je vlastne implementovaná táto horná časť. A tú dolnú časť robí vlastne Argo, že on má nakonfigurované repo, skontroluje si zmeny, teda či tam nejaký commit nepribudol, ak áno, tak si ho naklonuje, zdiskoverne teda manifesty a aplikuje ich do Kubernetesu. Ja som to prepísal teda ešte do takého krajšieho obrázka, že developer pushuje do repa, ten triggeruje teda build test pushne do image registra, zároveň spustí teda druhý job deploy, ktorý notifikuje iný deploy. Teoreticky by to mohol byť aj ten istý, ale mne sa páči, keď je to izolované. Teda v druhom v Gite je updateovanie tých manifestov a Argo pozoruje tie manifesty a to, čo je v Kubernetese. Ak tam nájde nejakú nezhodu, tak synchronizuje tú zmenu. A teda, ak nastaví resurse, že je potrebná nová verzia imidžu, tak tá sa stiahne z registra. Čiže to je asi celý taký workflow. Dobre. Dalo by sa povedať, že Argo je vlastne o synchronizovaní tých resursov. Okrem toho, ako základná funkcionalita, keď nasadíte projekt a nič nezapnete, tak vám iba ukáže, že niečo out of sync, ale cieľom je vlastne celý tento proces automatizovať. A ako to zautomatizovať, je vlastne o tej synchronizácii a má kopec nastavení, ktoré nám to môžu umožňovať, fine-tunovať, hrať sa s tým a dopredu to nastaviť tak, aby to fungovalo hladko. Je tu teda, keď zapneme automatickú synchronizáciu, tak hneď máme 3 voľby na začiatku. Prún, že či resursy, ktoré už tam nemajú byť, má automaticky odstraňovať. Allow empty, to znamená vyprázdniť všetky resursy spolu s aplikáciou. Self-heal je vlastne, keď zistí, že v Kubernetese nastala zmena a nie teda v Gite, tak či to má automaticky hneď opraviť alebo nie. Toto je trošku triky vec, lebo keď chceme niečo rýchlo debugovať, aby sme nemuseli za každým commitovať, tak niekedy je možno to mať užitočné aj vypnuté. Ale cieľový stav je mať všetko pozapínané a aby to fungovalo. Potom je tu ešte jeden taký prepínač, kde umožňujeme pridať do namespaceu anotácie a labely, ale to funguje iba s týmto sync option, create namespace. Ďalej používa fázy a wavy. Fázy sú predsync, synchronizácia, podsync. Presync a postsync sú vlastne hooky. To sú joby, ktoré je potrebné vykonať predtým, než ide niečo nasadiť. A každá táto fáza môže obsahovať jednu alebo viac vln v preklade. By default každý resource, ktorý Argo aplikuje, má vlnu 0. Sync wave 0. Ak chceme, aby sa to vykonal niečo skôr než druhé, včera sme práve v tom workshope mali takú situáciu, kedy ingress controller čakal na to, kým sa vlastne nasadí ingress a ten sa nemohol nasadiť, pokiaľ nebol ingress controller k dispozícii. Takže tam vznikol nejaký deadlock a my sme potrebovali nasadiť, znížiť ako keby túto hodnotu na -1, aby sa ingress nasadil pred tým ingress controller pred ingressom. Čiže toto je vlastne nejaký spôsob, ako ja to môžem dopredu zadefinovať, aby to fungovalo hladko. Potom sú tu hooky. To sú tie joby, ktoré fungujú ako že presync, postsync. Máme ešte aj hooky, keď failne, napríklad synchronizácia, to môžeme aj niečo rollbacknúť. Skip je vlastne vypnutý hook a sync je hook, ktorý beží zároveň spolu s nasadením resursov. A potom je tu ďalšia spústa iných synchronizačných prepínačov, ktoré nám umožňujú fine-tunovať, ako keby dopodrobna vylepšiť a zlepšiť tento proces. Nejdem ich všetky prechádzať, lebo ich je naozaj dosť. Tieto s hviezdičkou sú pre individuálne resursy. Tie bez hviezdičky, alebo kde je hviezdička v zátvorke, sú pre aplikáciu. Takže spomeňte napríklad na ten create namespace, ktorý tu bol na začiatku. To je, že keď chcem deployovať aplikácie do namespace, ktoré ešte neexistuje, tak ho automaticky vytvorí, celkom jednoduché. Potom je tu taký, že prune a delete vyzerajú rovnako, ale je medzi nimi rozdiel. Prune je vlastne klasické odstraňovanie resursov. Keď už v repe sa nenachádzajú, tak aby ich odstranilo alebo neodstranilo podľa želania z Kubernetes klastra. A delete je vlastne, že či sa má ten resource vymazať po vymazaní aplikácie. Takto môžeme si napríklad nakonfigurovať, že chceme ponechať persistence volume claim, aby sa nám nezahodili dáta, keď niekto omylom zmaže alebo sa zmaže aplikácia a chceme tie dáta nejakým spôsobom zachovať, lebo inak nie sú zálohované, napríklad takýmto spôsobom. To Dobre. Aplikácie. Písanie tých aplikácií môže byť niekedy otravné, hlavne keď projekty vznikajú a zanikajú a každý tým si ako keby aby sme nemuseli ako za každým písať aplikáciu pre každý tím, pre každý nový projekt, tak je možné nastaviť, nakonfigurovať generické ako generátory aplikácií pomocou aplikačných množín alebo setov. Teda aplikačný set umožňuje teda využívať tú funkcionalitu akoby autodiscovery, to je zmeny v našom Git repository. Tu by som povedal, že aplikačné sety sa hodia v podstate iba na projekty, ktoré sú vlastné alebo ktoré vyvíjajú sa ako keby aplikačné. Keď niečo nasadzujeme do Kubernetes core, ako napríklad ingress, monitoring alebo storage, tak tieto veci je lepšie mať nakonfigurované ručne. Je tam Potom môžem povedať aj, aké nuancy tam sú. Ručne nám umožňuje lepšiu kontrolu mať nad tým. A je to asi flexibilnejší spôsob, ale tieto aplikačné sety sú naozaj potrebné pre discovery. Generátory tých aplikácií je niekoľko typov. List generátor je jednoducho vymenovaný v poli počet jednotlivé aplikácie. Môžeme sa pozrieť možno ako taký list generátor vyzerá. Má tu list, to znamená, každý list má nejaké premenné a tie premenné môžeme aplikovať vlastne do templateu. A každý application set obsahuje template a to je vlastne špecifikácia pre aplikáciu. Čiže tiež tu môžeme takto konfigurovať target, teda source, že odkiaľ má brať zdroje a kde to má nasadzovať. Teda server, to je akože ktorý klaster, namespace je namespace v klastri. Čiže to je ukážka toho najjednoduchšieho listu. Potom je tu cluster generátor, ten sa hodí pre sety, ktoré chceme inštalovať do každého klastra. To je možno trochu výnimka oproti tomu, čo som povedal, že aplikácie sa ho platí písať na všetky teda inside resursy. Ale ak máme veľa tých klastrov a všade nasadzujeme to isté, tak sa nám hodí tento cluster generátor. Potom je tu Git generátor, ktorý je tak bežne využívaný ako discovery. On sa potom delí na dva typy, že bude tam adresár alebo nejaký konkrétny súbor. A my môžeme vlastne takto monitorovať čas Git repozitore. A keď sa tam niečo objaví, to využívam aj v tom, čo som vám ukazoval, že Git repository má nastavenú takú štruktúru, že v env, keď sa vytvorí nejaký súbor, tak to je vlastne každý jeden deployment. A on tu má parametre, ktoré potrebuje pre ten template. Možno ešte ako taký Git application set gitovsky vyzerá, tak tu je ukážka z reálneho použitia. Vlastne sledujem nejaké konkrétne repozitory, ktoré je vlastne konfiguračné, deployment a hľadám tam nejakú cestu. Viem tam aj odfiltrovať nejaké veci, ale v zásade, keď viem, čo tam dávam, tak to není treba. Dobre, ideme ďalej. Veľmi užitočný je CMS provider generátor. Ten umožňuje ako keby monitorovať veľa Gitov naraz. To znamená, že keď máme GitLab, tak ja môžem monitorovať celú skupinu Git repozitorov a tiež ho v praxi využívame. Pozriem sa, či tu mám ukážku. Áno. Tu je ukážka CMS nie, to je toho Git. Momentík. To je. CMS tu je. Pozrieme si tento jednoduchší. CMS provider, my máme teda interné GitLab, pozeráme na nejakú konkrétnu skupinu tých projektov, definujeme tu teda API, kde sa nachádza a ešte si tu môžeme definovať, či chceme monitorovať všetky branche alebo len main branche, lebo môžeme mať feature branche a takéto veci. To máme v tom druhom nakonfigurované. Či chceme inkludovať aj podskupiny, ak je tam zložitejšia hierarchia. A potom tu môžeme mať filtre. Napríklad môžeme si deployovať len z branchi, ktoré začínajú preview, aby nasadilo preview nejakej aplikácie a takéto veci. Čiže je veľmi užitočné pri developovaní. OK, vrátime sa do prezentácie. A ešte je tu teda pull request generátor. To je vlastne, keď vytvoríme, chceme robiť merge request. Potom je tu Cluster Decision Resource Generator, ktorý je asi taký najzložitejší. On na základe nejakých metrik vie rozhodnúť, do ktorého klastra vlastne aplikáciu nasadí. Tiež je to výhodné, keď je viacero klastrov. My ho zatiaľ nevyužívame. A je tu Matrix a Merge generátor, ktorý umožňuje kombinovať viacero generátorov dokopy. Čiže trošku už zložitejší koncept. Poďme ale ďalej. Veľmi dôležité na to, aby sme mohli používať Argo a nemali komitované secrety v Gite, čo je ako bad practice, potrebujeme secret management. My sme si zvolili Argo CD Vault plugin, pretože je asi najjednoduchší na použitie. Stačí pridať anotáciu a potom do hoci ktorého resursu a potom takýmto placeholderom, čo vyzerá ako HTML, tak vložiť si jednotlivé kľúče. Prípadne, ak nemôžeme pridať anotáciu alebo ju ťažké pridať, tak môžeme pridať takýto zložitejší placeholder, ktorý obsahuje všetky informácie v sebe. Je tu vlastne tento secret manager je nakonfigurovaný na Vault, ale podporuje aj iné veci, takže je to takto jednoducho použiteľné a pre nás dosť výhodné. Výhodou tohto secret managementu je, že nepotrebujeme nejaké prídavné resursy. Ja sa to tu pozriem. Ako napríklad, keď máme sealed secret, tak je vlastne navyše sealed secret, ktorý vygeneruje secret. Hej? A my ten vygenerovaný secret, jeho meno musíme niekde nakonfigurovať, ale Helm chart môže byť napísaný aj tak, že on si generuje ten secret sám a neumožňuje mi ho nasetapovať a takto je to vlastne univerzálne použiteľné. Tento Argo CD Vault plugin teda podporuje ešte aj ďalšie anotácie, to znamená, že viem vypnúť to rezolvovanie, ak tam mám v nejakom resurse niečo, čo sa na to podobá, ale nechcem, aby ich rezolvoval. Alebo keď mám v secrete secret, ktorý nemôže rezolvovať, pretože sa nenachádza vo volte, tak zasa mi vyhodí chybu, ale ja môžem nakonfigurovať, aby to radšej vymazal, že je to len optional. Potom sú tu modifikátory, to znamená, že za ten kľúč, ktorý idem inkludnúť, môžem ho enkodovať, dekodovať, parsovať, vyberať si, ak je to teda nejaký JSON, nejaké konkrétne kľúče a môžem ho nejako naformatovať alebo vytvoriť z toho len hash na label. Čiže To je asi tak všetko, čo by človek mohol podporovať. A výhoda je ešte aj ďalšia, že umožňuje teda, že nie je to len pre Vault, ale IBM Secret Provider, AWS, všetky takéto cloudové secret manažery sú vlastne podporované. Tu je ich zoznam. V tom workshope je vlastne ukážka, ako sa používa s Vaultom. Potom tu máme inštaláciu Argo CD, že ako ho ľahko môžeme nainštalovať prvýkrát. Ak inštalujete Argo CD prvýkrát, tak odporúčam možno použiť Argo CD Autopilot, repo Bootstrap, kde mu vlastne stačí URL do prázdneho repa a git token, aby mohol tam commitnúť zároveň nejakú štruktúru. Je to dobrý nástroj pre rýchly štart, ale nie až taký dobrý na neskoršie použitie, keď už to Argo poznáte. Lebo niečo je zastaralé a tak. Tu je taká ukážka, že čo vygeneruje ten Argo CD. On má takú štruktúru, že Bootstrap, kde deployuje aplikáciu ako Argo CD. Potom sú tu cluster resources, čo sú ako keby spoločné resurse pre viaceré aplikácie. Potom tu má adresár pre projekty a pre aplikácie. Ako náhle sa oboznámite s touto štruktúrou a možno si ju trošku upravíte podľa svojich potrieb, tak podľa môjho názoru už potom Argo CD Autopilot nepotrebujete. A ako je možné obnoviť klaster, ktorý je dole? To si môžeme aj ukázať. Mám tu klaster, ktorý je prázdny. Obsahuje v podstate 3 nody, 3 body a nejaké základné namespacey. Čerstvo nainštalovaný klaster a chcem do neho obnoviť klaster Maker Server. Ja to teraz spustím, lebo to chvíľku trvá. A teraz si pozrieme, že čo som to spustil. Tu je vlastne nejaká náhrada pre to Argo CD Autopilot. Je to nejaký snippet, ktorý som vytvoril, ktorý sa dá ktorý môže slúžiť ako návod, ako sa to vlastne robí. Tu je vysvetlené, ako pracuje, ako sa môže spustiť priamo a čo vlastne robí. Skontroluje teda repozitory, spustí, teda vytvorí namespace Argo CD, deployne základnú verziu. Argo CD potom môže sám seba updateovať na základe toho, čo je v Gite a nastaví teda, ak je potrebné, secret do toho Gitu. Potom deployne vlastne prvú tú aplikáciu, ktorá ukazuje na to Git a čaká, že kým všetko nabehne a nám to spustí. Čiže takto jednoducho vieme vlastne, keď máme všetky resursy manažované Argom, tak je pomerne ľahké urobiť disaster recovery, že komplet workload nasadiť z toho, čo už máme definované. Demo, to som vlastne teraz spustil. Pozrieme sa, či nám nabehne, ale to bude asi chvíľku trvať. Tak ja nebudem strácať čas. Tu mám nejaký odkaz, že kde začať. Táto knižočka, pomerne tenká, od Codefresh je také krásne intro, ako vlastne ten GitOps funguje, ako sa dá ako ho Argo CD implementuje. A ponúkajú aj learning kurzy, kde je Argo CD. Ja som ich ešte stihol, keď boli zadarmo, teraz je tam za nejaký malý poplatok celkom užitočné. Sú tie kurzy, pretože sa tam oboznámite nielen s Argom, ale cez neho aj s Argo Workflow a Argo a ďalšie tooly od Arga, ktoré sú tiež veľmi užitočné a tiež ich využívame. Môžeme prejsť na otázky. Ja nechám možno toto demo bežať, aby sme zistili, to už aj za chvíľku bude. Dobre, tu tu je v tomto deme teda ukazujem áno, nabehlo, už mi aj vypísalo heslo, ako sa môžem do toho Arga prihlásiť, takže ja sa do toho prázdneho klastra môžem prihlásiť a pozrieť, čo tam všetko je. Admin a vidím, že ešte Argo CD dobieha, tam má niečo, čo pomalšie štartuje a je tu vlastne všetko, čo potrebujem. Čiže takto vyzerá Argo CD a je pekné, že keď použijete ten Bootstrap, tak hneď tam aj vidíte nejakú aplikáciu, teda konkrétne to Argo. Umožňuje inspektovať resursy, napríklad pre pody vieme si pozrieť, aký má manifest, jeho logy a keď si nakonfigurujeme terminál, tak aj terminál. Ja možno, že aj ukážem konfiguráciu toho terminálu, lebo je to veľmi jednoduché. Ale môžeme možno prejsť na tie otázky. Pozrieme sa teda, či sú nejaké otázky. Nemusíme prepínať, lebo to mám tu. Zatiaľ nie sú. Takže využijem teda tú minútu na konfigurovanie toho terminálu. Teda trúfam si, lebo je to naozaj také ľahké. Skúperujem si túto zmenu, čo potrebujem nasadiť. Nájdem si definíciu pre Argo CD, ktorá je táto tu. A komitnem to. OK. A teraz si môžem pozrieť. Argo CD to už asi aj... Áno, teraz to zosynchronizovalo. A teraz, keď kliknem na pod, tak tu mám terminál a môžem si na ňom pracovať. Dobre. Tak, to je asi všetko. Ďakujem teda za pozornosť. Tu je ešte teda odkaz na tú...
Ešte máme jeden online dotaz, Argo alebo Flux.
Flux. Niekde som počul porovnanie, nemám osobnú skúsenosť s Fluxom, ale mňa zaujal ten Argo CD od začiatku a myslím, že to bola celkom dobrá voľba. Nepamätám si teraz už tie dôvody, ktoré povedali ľudia, teda, čo poznajú obidva nástroje, že prečo lepšie Argo, takže neviem vám na túto otázku asi lepšie odpovedať. Dobre. Ešte tam prebydlo? Už? Aha. Je to téma, je tam user management a policy management, airbag. Teda pomocou roly môžeme definovať to, kto má čomu prístup cez to Argo. A ja to chcem doplniť do toho workshopu a dúfam, že to čoskoro bude, lebo nie je to zložité, zatiaľ tá stránka ešte neexistuje. Ale my vlastne využívame, môžem možno ukázať taký example narýchlo, ako to vyzerá v reálnej praxi. Áno, to je vlastne v tomto repozitórii my máme tú štruktúru ešte trošku chaotickú. Argo CD, tu máme customization. A v podstate tu je nakonfigurovaný OECD na prihlásenie, tu je nakonfigurovaný voči GitLabu a Google, že môžem sa jedným alebo druhým prihlásiť. A takto vyzerá nejak airbag. To sú role, že pomocou toho, že v akej skupine v GitLabe sa človek nachádza, tak mu je priradená rola a každá rola má špecifikované, čo môže robiť s aplikáciou, s inými resursami, s ktorým projektom, či ich teda môže mazať, synchronizovať, updateovať, alebo ak chce spúšťať terminál, tak na to je špeciálna rola exec, create, aby mohol pozerať aj terminál. Takže takto to nejako vyzerá. Pridám to do toho workshopu, ako vás to teda zaujíma. Neviem síce ako, kedy, ale to som skočil ďaleko. Ups. Takže to je všetko. Management Argo CD bez použitia GUI, skúsenosti. Ja mám to GUI veľmi rád, pretože mi dáva taký rýchly vhľad do toho, ale nepoužívam ho v zásade na nejakú prácu. Je len ako keby na kontrolu, či to, čo som nasadil cez Git alebo cez command line, že či sa mi to tam objavilo. A prípadne jediné, na čo ho používam, na urýchlenie synchronizácie a teda kontrolu, že či je všetko, ale nie je potrebné to GUI. A vlastne je to len taký nástroj, ktorý pomáha transformovať. Ideálny spôsob potom, keď už máte všetko vyladené, tak Argo vlastne do toho GUI ani nemusíte pozerať. Len commitnete do Git repository a hneď sa to aplikuje. Čiže to je asi taká skúsenosť, že čím ďalej tým sa bude používať menej a menej. Ale na adaptovanie toho GitOps princípu je veľmi nápomocné. Dobre, ďakujem za pozornosť.
Well, okay. Well, I don't know when is the right time to start. Yes, so we are waiting for a click just now. Okay, hello. Hi, my name is Viroš Kaplan. I have some Twitter. I'm posting some pictures of Bratislava to it. And sometimes something about tech. And I'm here to talk about Kubernetes operators in Python. Well, about me, I'm a freelance server administrator. In fact, I started my career as a Python developer somewhere in the last century. And I found that Python is a really cool tool. It's a really nice programming language. I'm still using it. And when I'm given a task, how to please do something, then I'm trying to do it with Python because I don't know any other language as good as Python. So I'm using Python. So I'm playing with servers, and at the moment I'm a freelancer, and with my colleagues we are deploying and running applications for our clients. And we are on Kubernetes Community Days, and so I'm here because we are doing the deployment of our clients' applications on Kubernetes. You probably already saw this image. It's a Kubernetes. It's, as somebody told a few talks before, Kubernetes, it's a big playground, and you can use the small pieces to put some platform, to put the pieces together and create some great platform. And this is what we are doing at the moment. Well, there was a great talk about operators. How do operators in Kubernetes work? How do operators in Kubernetes work? What they are doing? So we can talk about it maybe, or maybe we can skip this. Well, and I would like to talk about my use case about Python and Kubernetes operators. We have a customer, or we had a customer, he asked us. I would like just to run some Python scripts somewhere. I would just like one Python script and then stop. And when the script is done, I would like to throw it away and just run another. He didn't want to persist the output. He didn't need to keep the sources. He just wanted to start the script and continue and go away. So, at the time, we just found Kubernetes. And do you know now the principle of hammer? When you have a hammer, then everything in your vicinity looks like a nail. So say, well, we have a cool tool. We have Kubernetes. We are going to use Kubernetes. So, and when you want to start one Kubernetes pod with Python, it can be done in this way. You will just start pod. You have to name it. You have to put some env Python application. You have to provide application to the pod. And it's a lot of YAML. Oh, I see a lot of YAMLs. So, and I don't like YAMLs very much. So, and I said, well, so bad. The idea, and I was thinking, it would be nice if it would be nice to have some simple Kubernetes object. I will just put some Python code into Kubernetes. Some magic is then will happen, and the code will be run. So, is it possible? Yes, it's possible. It's possible. There is a Kubernetes operator. At the time, I found again principle of hammer. at that time, I found Kubernetes operators and custom resources, and I said, well, it would be really good if we can create some custom resource. It will be called, for example, Python job or Python script. We will put some Python code into the custom resource, and the operator will start the job, or will create pods, and it will do the black work in the background. So, for the people which weren't present in the morning, operator concept, operator pattern is when should work in like an image. I would like to run some container with Python. It's here. This is a container which will be managed by Python, and just to get the container running, I can do it either manually. I don't want. We saw the YAML, or we can hire the operator. The guy inside is the operator. Operator is somebody who is given task. Please do this, and he or it will do the tasks for us. So there was when we started writing operators, there was presentation in the morning. The guy showed us we can use Go, we can use Java, we can use some operator framework and so on. It's possible to write operators in a pure Python. When you have your Kubernetes API, it has some definition. I don't know, it's called probably Open API specification or something like that. And there is a Python module called Kubernetes, and all the objects which are defined in the Kubernetes API specification are present in the Python module. So you can. This is an example for my very first try how to do a Python operator. We tried to modify some ingresses. So in Python, it means just open networking API. Okay, please get all objects from the API. This is the control loop. Please open all objects or list or watch all objects or ingress objects in all namespaces from the network API, and do some loop. This looks too much or too close to the Go approach. We just have to do the loop ourselves. It's ugly. It worked. It probably works. It probably still works because we forgot to update it at the customer side. But this is ugly. I don't know. Is anybody here who knows Python or who is using Python? Thank you very much. Do you know Zen of Python? There is a Zen hidden in the Python. When you ask Python, please import this, it will write 10 commandments of Python. And one of the commandments of Python is beautiful is better than ugly. Well, this is ugly. This looks like Go or some low-level language. So I was thinking it would be nice if there would be some more Pythonic API for operators. And there is. There is Kubernetes operator, there is Kopf. It's a shortcut from Kubernetes operators framework. It has some web pages. It has some documentation. It's on GitHub. The life of the Kubernetes, the Kopf, started at Zalando. At the moment, Zalando left it. Some guy from Germany takes care of the Kopf, and he still releases new versions. So I hope it will work for some time. And the Kopf is a Pythonic way how to do a Python operators. For me, well, at the end of this talk, I will tell you that we created a useful operator in 200 lines of code, which was really impressive to me when I counted that. So, and how we achieved that. So the basic concepts are there are hooks and handlers. When the operator, it doesn't matter if I wrote it in Go, or in Java, or in Python, it just should watch some Kubernetes API objects, and when the object changes its state, something should happen. So, for example, I would like to watch creation of object Python job. So I will create a Python function. The function should be named, for example, onUpCreate. And I use Python decorator from COPF, and it's called COPF onCreate. And here, API group, API version, API plural. These are the strings. There should be, I don't know. There should be our API group, version, and name of the object. And the COPF starts. The COPF framework starts with my program. And when new custom resource object with this plural is created, then this function is called. So for me, it's really convenient because I don't have to write some ugly loops. I can bind the COPF to multiple object types. I don't have to take care about, for example, coroutines and threads or some ugly low-level tasks. I will just say, well, when a new object is created, call this. This is a hook, or the concept. The COPF concept, basic COPF concepts are hooks and handlers, and this is on. Well, if you want to copy it or reproduce it, the demo is already on GitHub. So this QR code, this is on my GitHub. It's my favorite code because I get 3 stars on GitHub. And there is also README, so you can try to use it. And I should start Minikube. Minikube. I will start a new Minikube. Just to talk. Just to have talk. So let's use the demo. I should. At the beginning, well, it would be. I would like to create a new object, new custom resource, which is called Python app. It has some API version. It's our company, and we won. And my wish is that I create this object. The source is probably linked to the config map. Image name is image I would like to start. Python image I would like to use for starting the script. And time limit seconds, it's a timeout which should be set on the final job. So this is a job. So is it started? No. I forgot to start Minikube before the talk. When I create this new object, COPF isn't able, or I don't know if it's possible, but I haven't found at the moment a way how to create custom resource definitions. So I have create my custom resource definition in the beginning. Now starting, nice. I create this object, and then it started, great. And then I run my COPF. COPF is similar to Flask or something, or it's some main program. I say run this script, and work for all namespaces. And COPF starts, and when it finds a new Python app, it creates a new job. The new job, it's a Kubernetes native controller. It spins up a new pod. When the job is finished, I will update the Python application object again, saying it's finished. So at the beginning, I should create custom resource definition. So let's start. Yes, I need to start virtual env. This is Python Magic, which is de facto standard. Now, I already prepared conf. I already installed it to my virtual env, so I can use it. I can use it. And now I should create. Let's check the cheat sheet. Let's check the cheat sheet. This one. So at the beginning, I should create a custom resource definition. So I created new object, name it Python app. So show me, explain, Python apps. It's there. It has some specifications and so on. So now I should start conf. Okay. Conf main verbose. I'm starting it verbose just to show more bells and whistles. Well, it starts conf. There is a some. It's the core of the operator frameworks. Core of the operator framework. It does a lot of things for me. A lot of features for me. And now I can create the object. So create kube control, apply, f manifests hello world. We can check that at hello world hello world. There is a config map saying just a small script which says hello world, sleeps for 10 seconds, and then it says goodbye world. And then there is an object Python app which is doing all the magic. So create kube code. Now I'm starting the hello world, and you can see that the conf operator wakes up. It says well, something like where it is. It says well, here is some new object named Python app started. And what happens next? You can see Python app exists. Kube control get Python app. It's there. The operator, my operator creates a new job. The job itself starts a port, and we can check the logs of the object, and it worked easy. So what happened in the background? As I told before, there are only hooks and handlers. So when new application, new custom resource was created, the on upgrade was called, so the Python code found, well, we have a new object, and conf provides us with some helpers, and one of the helpers is named event, and we can say, you can check kube control, describe Python app hello world, and you can see that some event was created. You see? So it's from the operator itself. We can also call the Kubernetes API. So when we found an event, some object was created. Yes. So we can check the from the Python code, we can check state of the object, of the custom resource object, and I checked here. Well, is there annotation with the job name? And when the job of the Python when the Kubernetes job relating to the Python job wasn't created at the moment, I just create that. The COP provides us with some help tools, some helpers. We can easily access the annotations, the metadata of the objects. We can access them in a Pythonic way. So these are converted to Python objects, which is really helpful. So you would like to create a new object. Creating new object for the new object of the type job. Here, when I create a new object, I'm using Kubernetes API. I will just call it client batch API, called create namespace job, and it's created. Again, it's nice in Python. In Kubernetes, we can use owner references. Owner references are bindings between Kubernetes objects. When I would like Kubernetes to delete Python the Kubernetes job when my Python job is deleted. To achieve this, I should set the owner reference. Can say kube control get job, kube control edit job. We can see I would like to create owner references like this. In the raw Kubernetes API, it's ugly to set these objects. In COP, I will just say, please adopt that object. It just says the references. The COP itself is able to handle not only the custom resources I'm working with, it's also be bound to, for example, jobs or to standard Kubernetes objects. It can do some filtering. So when the job itself is finished, I can take the results of the job and put it to my custom resource. Yes, it's able to do some patch, and you see the job is done. This all simple proof of concept Python operator for running Python scripts took me about 190 lines of code, which is pretty impressive to me. Because, well, in Go, it would take me much longer time and probably more code than this. So, what COP can do what COP can do for us, it has built-in change detection. So when my handler is woken or has been woken up because some change of the object, COP sends me also a change object, so I can see what was changed, which fields are changed. It provides us with timers, so I can ask COP, please, I fed at the moment, wake me up in 1 hour or in a few seconds. And it can also handle retries for me. So that's at the moment. That's end of my talk. And probably now it's time for questions and answers. So yeah, it still runs.
Yeah, we have two.
Two questions. What is better than YAML?
In the beginning of a presentation, you stated you basically
I don't like YAML.
hate YAML.
No, I never told. I don't like it.
Yeah, you don't like it, but you have to use it.
It's like potatoes. No, it's like tomatoes. I don't like them, but I don't hate them.
Yeah. Okay.
Well, YAML, it's ugly, but at the moment it's probably the best we have. So we will
inevitable, yeah.
But I don't know. Well, at least it's better than JSON. Compared to JSON and XML, YAML is great. Well,
okay.
How did you create CRD? Well, when people asked me what I'm doing, I'm telling them I'm copy and paste engineer. I'm copying code from the internet and pasting it into their systems. I just build deployment. Is there? CRDs. I just copied some CRD that looked nice to me, modified it according to documentation, and it worked. So I expect that it's okay. Until somebody...
Can I continue? Because it's
Yes?
What is the difference between Golang? I don't hate dynamic language for
Yes.
business logic, I can say, because many programs can create. Golang, you create structures and you generate CRD. So you have one-to-one definitions.
Great.
But you don't have this in the Python. So
Good point.
For me, it is a little dangerous because second question maybe for this, you directly create some resource, but I didn't see which versions of the API you use. And Kubernetes support multiple API for kinds. And this can create some problems maybe if you don't know what you're doing.
Yes, if you are definitely true. Well, I don't know, or I'm not able to write in Go as good code as in Python. So, and it takes me, I started the COP for creating proof of concept of code. It worked. It worked good. It was good enough. So we stayed with that. For me, the COP is really convenient that I can stay in Python, and I'm probably much faster using the helpers that COP provides me than doing it in a pure Go. So for me, the selling point for COP is a speed of prototyping. Well, the great disadvantage, is there no question for disadvantages? Well, COP is a Python, so it means the image will have probably 50 or 100 megabytes, which is much bigger than the Go-based operators. The operators in Go, I expect it will be at least 10 or 20 megabytes, probably smaller. Is it? So this is a disadvantage of the Python operator, or the COP operators. But well, in our company, most of people can read Python, and only 1.5% can read Go.
Doesn't make sense for me.
Okay.
The half person, or?
Okay, so it has some advantages, it has some disadvantages, but the helpers are really convenient, like the hooks and so on.
Cool, thank you for the question. We've got one from Tomato. Do you run your COP in VMs, bare metal, or... Well,
the COP itself is a Python program, so for the demonstration, for the demo, I run it on my laptop outside the cluster. In production, we run it in the cluster alongside the workload it takes care of. So I don't know, it was probably some cloud. I don't remember. Well.
Yeah, in the end, it's VM, yeah. Any other question in the audience?
Okay.
Well, we can leave it. Thank you very much for the presentation.
Oh, you can destroy them. Delete. And it's over.